It is working for me. So maybe just remove all the cache or something from your browser, Gaush. That should work.
Yeah, sure. Yeah, I'm trying it.
If it still do not work, Gaush, then just coordinate with Lakshmi. She will assist you connecting with the cloud team.
Yeah, sure, sure.
Others are able to access.
Yeah, basically what Gaush is saying is that he's facing one side issue on you in connecting with it. So that's one component of their cloud. So I've just suggested him to try in a different browser because it's working for me. In case if it do not work, if you can maybe connect Gaush or maybe you can just take his account details and ask the cloud team to look at it.
Okay. Noted, Shivank.
Okay, let me share my screen, guys. All of you can see my screen?
Yes, Shivank.
Perfect. So let's start. How many people have joined? I didn't check that. Okay, we have just 2 people missing, but we can start anyway. So let's have a quick revision of what we have discussed in the last session. In the last session, we finished off a case study for Apache Hive. Case study for Apache Hive. How many of you have worked over it? It's already uploaded yesterday after the class itself. How many of you have worked over it? No one? Okay, guys, just try that. This is, I think, the first case study where I gave you just 50% of it to do it as homework. I know you guys do not have the time. That's the reason I'm trying my level best to cover as much as possible case studies within the class, but still try to do it. Otherwise, if you look at the solution, it may not help. Now, second thing which we discussed after that was we started with NoSQL DB. We got an understanding of it, like how NoSQL DB works, and we saw the challenges with respect to SQL DB. When it comes to huge data, then it's a big problem. You have a very fixed schema. This was another big problem. And you want to change something, it will be a big trouble there. Then further to that, you also have problem when you have a lot of missing data information. Basically, that missing data is also eating up your storage component. That was another big issue with respect to your SQL DBs. So all these issues we have discussed. Then I also introduce you with something called as column family. So I explained you that in column family, it's like we want to have a denormalized data instead of having a normalized data. And we try to keep that as it is. For example, let's say if I have a data set, something like this, I have a row key as one column. And inside this row key, maybe I will have the data set something like this. So maybe I will have this up. I have, let's say, a personal column. And within this personal column, I have some data set like name. This is going to be like this. Then after that, I will have an age column. This is again going to be in this manner. Then after that, let's say I have a gender column. Okay. So now this personal becomes the column family here. Similarly, I could have other activities here. Let's say I have contact. Now for this contact, I may have columns like, let's say, mobile. Within that, I have another one, let's say, which is email. I'm just randomly noting down some column names because I will be using it to show some differences quickly. Then further to this, I will have an employment. Maybe this employment column family have maybe something like, let's say, company maybe another column as date of joining, third one as, let's say, designation. Okay, let's say my data is like this. Now in this case, the way the data will be written will be something like this. So let's say I would say row 1, right? And my data will be, let's say, going something here. Let's say ABCD. I'm just writing quickly. Maybe then I have some age, maybe it's male, and so on, right? All the data will be pushed on here. I want to show you one interesting thing here. So let's say my data is kept like this, right? Now, this is just a visual representation for you to understand it. Now here, let's say if I talk about this part, this mobile, maybe I have 1, 2, 3, 4, 5, 6, 7, 8. This is one mobile number. And maybe here I have another mobile number as, let's say, 987160052. Similarly here, if I talk about maybe for email, I have, let's say, a@of g.com, and here it is b@of gmail.com, like this. And then maybe in company, I have, let's say, Google, designation or date of joining, whatever I want to place. Then again, here also I'm placing something, right? So if you look at this, what is happening here? This is the concept which I already explained you. Can you tell me why this is being written in 2 times like this here? This is the logical view, but can you tell me why in a row 1 itself, I'm writing it 2 times?
Because rest of the data is repeated and the same person can have 2 phone numbers and 2 email IDs.
No, no, that's not going to be the case. Anything else?
It's the denormalized form of writing.
Denormalize, that's okay, but can you say a little more about it? Yesterday I talked about this portion already. So if you recall, I talked about
It's a
something.
columnar family, that's why.
Yeah, column family is okay. But yesterday, recall, I discussed about something with versioning. Now, can anybody recall what was versioning? What was my versioning? If you recall, I explained you in HBase, we keep the data on top of SDFS only, right? Now in SDFS, we cannot update the data as such. So what we do, we store it with the help of timestamp. So what is happening now, that whatever data you store, it will not be deleted, but after that, whatever you're writing, this will be the latest timestamp. So when you will retrieve it, it will get retrieved with the latest version. Okay. If you still want to see the older versions, you can do that. Just like in this particular example, if I go back here and want to retrieve even this value, I can do that. In RDBMS, this value would have overridden on it. But in HBase, if you are adding more and more versions, it's allowed, but it will be logically stored in this manner. Clear, everyone? This is the logical storage. Now let me tell you how this is going to be physically sort of stored, right? How basically HBase table sort of looks like. So for this, let me show you what's the format for it. It's a JSON format again, which we use it for it. So for example, here it's going to be, let's say, row key. Here I will be having my column family name. Then here I will be having my column qualifier. I'm just writing with a shortcut Q. Then I will be having my timestamp. And then further to that, I will have my actual value, which I'm going to store. So what is the way it's going to be stored now? So first thing first, let's say I will say row key is row 1. So it will say row 1. Column family, let's pick up any, let's say contact. Okay, contact. Now here, let's say contact, I just want to pull up, let's say email. This is your column qualifier. What timestamp it have placed? Let's say 100. What is the value for it? The value was a@of gmail.com. This way. Now what's going to happen? Let's keep up the second value. So let's say again row 1, because it's a row 1 value. Again contact, again email. This time, let's say the timestamp is 200 because it's the latest timestamp. Now it got changed to b@gmail.com. Let's pick up another one. Let's say again row 1. Now this time again contact. This time let's say mobile. What is the timestamp it got stored? Let's say 100. The value was 1, 2, 3, 4, 5, 6, 7, 8. Similarly for row 1, it will at the 200 timestamp, it will place the other value. Then, so I'm not writing it this step. For 200 timestamp, it's some other value. Then again row 1. Now let's say we want to pick up any other one, like employment. When I say employment, basically this is my column family. Now within that, what is this? Company. For company, at what timestamp I inserted the data? Let's say 100 timestamp I inserted the data. What is the value I inserted? Google. This is what is called as column oriented storage. So here, what we are doing is we are storing it more like a key value pair. And what is exactly happening? So let's say I have a row 2. In my row 2, let's say all these are blank. All these are blank. Maybe only the value for row 2 is B, C, D. That's it. I have all the other data as blank. In RDBMS, it will be stored as null, right? But here, it will be just stored like, it will say, hey, I am row 2. I have the column family as, let's say, personal. In my personal, I have name. I have, then after that, whatever timestamp I stored, let's say it's at 300 timestamp. Then what is the value? It is the BCD. That's it. After that, I will not insert anything belonging to row 2. I'm not even doing the null insertion here. So maybe after that, I can start with row 3 itself and move on with other values. But I'm not bothered about row 2. So whenever new data for row 2 will come up later also, I can just add it like a JSON entry for it. So that way, we are not ending up wasting any space as well. Everyone clear with this part? How this storage internally for HBase looks like? Now, how it is retrieved and all, I will just show you with the code part. But first of all, this portion is clear to everyone. Any questions on this? No? Okay. Now, let's go to my queue. Yeah, somebody was asking something.
Yes, Pradeep here. So, Sivan, what would be the column there so we can identify as a unit? Is there any internally column will create like timestamp something in HBase?
The column is again represented by a column family itself, right?
Yeah. So this rows are there. So any column, anything extra which we can say it's identical things there.
You mean
except
to say
the timestamp.
No, timestamp is the main thing using which you will distinguish which is the latest entry for you. But other than that, if you want to uniquely identify a row, then it will be with a row ID, which is the first record. Like we said, row 1, row. Okay. So what I will do now, let me connect you with this shell. And even for you, Pradeep, you will get more answers right away when I will execute this particular code in front of you. Because this will also give you a lot of details. So first thing first, let's basically quickly see how we go inside my HBase. So let me make this a little bigger. I will say HBase shell. I'm inside HBase shell. Now, once I'm inside it, what we will do here is I can say, I want to create maybe a table. Let's call it as, let's say, in fact, let me do one thing. First, let me do a list command. Let me show you what this will do. If you do a list command, this will show you all the available tables and everything which you need. So you can see so many people might have created here. All the details, you can check it out. Now, similar to that, let's say you want to create a table. Let's call it as, let's say, details. Okay. So I would say create details. Now, what are my column families I want inside it? I want a user column family, comma, I want a product column family. Now, in order to distinguish it easily, let me call it as maybe Shivang. Okay. Otherwise, the problem is there are so many lists, you will find it difficult to search. Let's call it as Shiva. Okay. So you can see that this got created. You can say that it's telling you that it took some 0.7859 and the table name is Shiva. If you do a list of it, you can see also this Shiva being shown up for you here, right? So this is the way you will be sort of creating a table. As you can see, the syntax is little weird here. That's what I told you in yesterday's session, that HBase have a slight learning curve in terms of syntax, because this is completely sort of a new syntax for everyone. So once we have created this up, so first thing is what I want to do is I would like to see this Shiva, that what are the things within it. So I can say, hey, go ahead and describe Shiva for me. So you can see it will show you so many details for that. It will show you that I have a column family called as product inside it. I have a column family which have a user within it. The version for this is 1, because you can also go and change maybe the name of your column family using some commands. So the version is this. And then I have so many other details. Not everything is useful for you, because if I have to tell you, it will go into little advanced concept. But you can notice few things which are helpful. For example, TTL, time to live. What do you mean by time to live? Have you seen in your e-commerce, sometimes they show you a deal. They say that, hey, this deal is only for next 24 hours, and they run a timer on that. And as soon as that timer gets closed, that deal is over. So this can act like a time to live. So let's say you inserted a row into your table and you said that I want to insert this row only for next 24 hours. So what will happen after your 24 hours, that row will automatically get deleted. You don't need to do anything for that. So that is what how one way you can define your TTL values. So right now it's none because I have not defined it, but these are something which is important. Similarly, there are a lot many things, like you can have compression. There is something called as Bloom filter. This is coming from the algorithmic concepts, data structures in algorithm. Like it makes the searching really, really fast and basically really superb around it. But you can go and read about that if you're more interested to it. Similarly, you have block sizes and all those details as well when you have created this particular table. Now, what I will do with this, once I have done this, I want to insert some record inside that. So now when I want to insert, I would say, hey, take a put for me. I want to insert in Shiva. I want to basically use this up. I want to create a row 1, which is going to be the same way a row identifier for me. You can think of it like a primary key. Now, after that, I'm going to say, hey, I have created a user column family. So I'm going to say user. Now, inside user column family, I want to create a column. And let's call this column name as name. So inside this user column family, I'm defining this as this. And then I can say, hey, let me insert some data for it. Let's say I call it as Abhishek. Okay. So I will just insert this data now using this medium. Let me execute this. You can see that I can see this particular output here. So I said in my Shivang table, which I have created, go to my row 1. Row 1 is the unique identifier. Take my column family as user, because when I've created the table itself, I said that I have 2 column families. One is product and second is user. And then I'm going to say that within that column family user, I have basically a column name called as name. And inside this name, I'm inserting this value as Abhishek. So this is the way we will be inserting the data inside this particular table. Now, if you want to see this output, maybe I just inserted one record, but I want to see this particular output. So you can say that scan, and you can define, I want to scan maybe Shivank record, basically what are the values inside it. So you can see here, it is going to return you the output also in this format, which is row one. And you can see all the values, like at what timestamp it got inserted, what was the actual value for it. And the row was like row one. So this is the way you can also check your output as well. Now, what I want all of you to do is quickly, so that you get a little bit hands-on on this. Can you go ahead and quickly connect to your HBase shell, do a list. You should be also able to see this Shiva, but I suggest you to create by your own name, a table. So you can quickly create a table also. I can show you that command as well so that it's easy for you. This is a part. Then after that, you can do a describe of it and start inserting the data. I want you to insert at least 2 rows inside it. Create your own column families, create your own. So I would suggest create your own column families on a paper first so that you know that how you will be inserting your data, and then go ahead and insert it here. Can you all quickly do that? And to connect to HBase, you have to say HBase space shell. Okay, that will help you to connect to HBase. If you have any questions, please ask me.
Hello.
Yes.
Can we insert multiple columns at once?
Not using.
Sorry?
Not, there are other ways. Maybe I can just give you the details how you can do that as well, so that you get at least an insight. But that's other ways how you can do that. Connecting in this HBase shell, no, you cannot. Okay, Gaush is done. Whoever is complete, please keep on pinging on the message box so that I know that you have completed. In fact, Gaush, how many columns you created, and means how many column families you created and how many rows you inserted?
Shivang, I have created 2 columns and I have inserted 3 rows individually.
Okay. So three people have done. Aditi and Manju have also done. What about rest? Surbhi is also done. Maybe take another 1 more minute and complete it. It's a very simple exercise. Okay. So all people who have done this, can you just try this part now? Let's say I have already inserted this record here, right? By stating that put command in row 1 for username Abhishek. You change it to something else. Let's say you make it Abhi. I change it up. And then if you do a scan, are you seeing the older value or are you seeing the new value? Can you quickly check that?
So new value has overwritten that, and we are only seeing. I am only seeing the new value.
I am also seeing new value.
All of you seeing the new data? This
Yes.
is because of your timestamp. The latest timestamp is being taken out. Now, another way to also do this, because I have just created a small table, you guys can actually try it your end. So what you can do is, let's say you want to only read row 1. You don't want all the rows. So you can say get Shivang, and then you can define whatever row you have defined. Let's say row 2 you have given in case. So give row 2 in your case and execute it. You should be able to see only that particular row. Can you just try that quickly at your end? For me, just one insertion because I didn't do any change to it. Again, a very small command. Let me know if you're able to see that. Done? Okay. Now, similar way you have delete command. You also have commands like, even in your scan itself, you can say, hey, I'm interested in this column family. For this column means, let me just quickly show you the syntax. Let's say I could have said that, hey, I have this table T, let's say inside this T, what I want to do is, let's say there's a columns, and inside this column, you can define the details. Let's say you say there's a column family A. Now inside this column family A, let's say you have a call 1, which is a column 1 for it, comma, you can say I have another column family B. Okay. In this column family, maybe I'm interested in, let's say, call 2 in this part, and you can give it. So this will also kind of give you the result for specific columns as well. I'm not going into all this code syntaxes because we have to just touch base on this to give you the idea how this looks like. Similar way, you could have said that delete your table name, comma, your column family, and so on. So that will help you to delete these records. So one main thing which I wanted to convey to you was that the way it works, and at the same time, when you're doing this right now in a shell, you are inserting it one by one row, which is, you cannot do it like that. So how we generally do it in the real world, like when I get the projects, how I work across it. First of all, HBase is having a connection very well with your Java. So you can write a Java code for all this, put command, scan command, delete command. There's a Java code which you can write. And that Java code, we can keep putting one input for it and it will work for you. That's one way to go for it. Second way, which I want to also talk about is, with the help of some streaming activities, you can also bring the data. For example, maybe you have a Flume code. We have not learned Flume, but this is one to bring your unstructured or semi-structured data. Similarly, if we have, let's say, Apache Kafka, right? We will be learning about this in the last class. So all these using these components also, you can directly insert your HBase with a big data set coming in. So this is a general way how we sort of insert the data in the practical scenario. The reason being, HBase is pretty huge. Pretty means, when I say pretty huge, the data what you're going to insert will be pretty huge because you're normally going to work on the data set which is going to be huge. Even a lot of times I came across situations where my data is sitting in Apache Hive and I have to basically place this down to HBase to do something which is more relevant for HBase. Or even not just HBase, but also with, let's say, things like Cassandra or MongoDB. So the way we then create those connectors will be a little different, but we can basically transfer these data as well. So this is more of an industrial way how you will be working. Though definitely, even in these codes, the command which you have learned will remain the same. It's not going to change. So you will still be using the port command. You will still be using the get command, but it's just that you have to apply those connectors and pass on the data. So just to kind of give you this inference so that you have this idea that in real world, how you will be doing it, how you will be inserting all these records to get across all this. Now, So this is about your NoSQL DB. Like I said, I will be only talking about this for half an hour in the starting so that we can move to our next topic. First of all, any questions on this point? I know we have not gone into that. In fact, this NoSQL DB is such a big topic that I can easily talk for almost a complete day or 2 days on it. In fact, I've taken trainings just on NoSQL DB for 3 days, which is almost for 24 hours. This is such a huge topic to talk about. So I have only compressed it for you guys, keeping in mind the time constraint, and we have to only talk and touch at the very high level on this portion. But any questions on this part? Okay. Now we will be moving to Apache Spark. This is going to be interesting. Okay. Now, let me put some context here, how we will be approaching it up. Apache Spark is supported using various programming languages. Like you have Scala, you have Java, you have Python. You also have R now supported, especially for the AI aspects, but let's keep these three as a major programming language. Now, I want to keep Apache Spark independent of these programming languages. Definitely for everything, I will keep showing you the Python code a bit so that you get an idea about this part. But sometime I will also bring you some portion of Scala. I will also be teaching you some portion of Scala in the class. So we will also be talking about that, how we write the function programming and some basic construct which you need for Apache Spark. But I will keep bringing some different programming language mix up also sometimes along with Python, which will also be there to give you an insight how this works. The main reason why I'm doing this is Apache Spark, first of all, it's very important for you to understand the concepts. It's very important. Means you should be really good how Apache Spark works with respect to any programming language what you have. And the base of Apache Spark should be really strong because you will come across majority of the project with Apache Spark. Second thing is, a lot of times since you guys are also going to interact with different clients, I have come across these situations quite often where some companies have already some legacy code written in some language and they basically expect you to follow the same. This can come up in front of you. So though maybe, let's say if I show you some code in Java, and again, immediately after that, I will show you the same thing in Python also. But the intention of showing you that quick Java code is so that tomorrow, if that code at least come in front of you from that client, you should not panic. You should get an idea, okay, this is what it is doing, because it looks very much similar even in terms of if you write in Python or in Scala, it doesn't matter. So this is going to be the intention to bring up, but again, it will be very quick. In fact, you will find that this is already written with me. So I will just very quickly show you the main construct around it. So that's going to be another thing. Then one more point is keep your labs open, because I think even from today class itself and tomorrow class also, we will be doing a lot of case studies. The challenge is if you just try to mug up those APIs which are available in Spark, it will not help you. You should really know how to apply them up. How basically if you come across a real-time project, how you should be applying that stuff. So that's the reason there will be some case studies which I will keep on pushing in the session. So that you have to use all the context which you have built up and sort of do it. I think by tomorrow we may solve some 3 case studies. Let me see how much I can bring up. But there will be a lot of learning with the help of case studies. That is going to be for sure. Okay. So that's something you have to be ready with, because it's going to be very interesting. And at the same time, let's keep it more practical around it. I will also keep on bringing wherever relevant my own experiences, that how we solve these type of problems or what kind of challenges generally comes in middle when we talk about Apache Spark. Now, what are the major concepts we are going to talk about? One is the Spark core. This is going to be the most important one, because on top of Spark core, everything is written. Second thing would be Spark SQL. We will be spending again a considerable amount of time on that because this is also going to be very, very interesting. And one thing which I will also bring up here is with the help of Databricks. I will show you how you can run it on your local clusters, but also how you can run it on your Databricks. Again, with an intention, most of my clients also are working on Databricks. This became really famous in the market. So at least you should know how this platform looks like and how you can write a code. It will hardly take me to explain you 10, 15 minutes on this. But once you have this knowledge, at least if something comes up, you should be able to easily cope up with that. Now, then further to this, I will be very briefly talking about Spark streaming. I'm not going to go into depth into this portion because of the time. We will not be getting much time around it. So this is going to be kind of a very basic strength which I will be talking about. If the time permits, maybe I can cover at least the basic level of Spark MLIP, but I really doubt we will get this time for this part. I'm keeping it as an extra topic just in case if we get the time, because these two will be the major chunk which will eat up your time and majority of your project will fall into this domain. For Spark MLIP, it's a machine learning stuff. So you need to have the knowledge of basically machine learning. So it will not be useful for people who do not know machine learning. That's the reason I'm keeping it very tentative right now. So this will be the overall agenda which we are going to kind of process with it in Apache Spark. Any questions or anything which you want to talk before I start on this now? Perfect. So let's get back again to our older problem. If you recall, this was my cluster. Okay. I have a file. Let's call this as f.txt and it has some data. Okay. This file is, let's say, of 384 MB. Okay. Second thing is, maybe in this particular part, maybe this is my RAM for this system. I have drawn it outside because I may have to write a lot of things inside it. So this is my RAM. The square box is the RAM of these systems. Okay. Now the first thing is when I'm working across with this. So since it's a 384 MB file, definitely my F1 is going to set here. My F2 is going to set here. My F3 is this. So let's say that in my data node 1, this is setting. My data node 2, this is setting. My data node 3, this is setting. Okay. Again, let's forget about replication for a few minutes. I will bring that also in some time. Now, what's going to happen in this case? Okay, let me keep making space here. So for making space, maybe I can remove all this. And guys, I need your attention. This is going to be for almost half an hour diagram. And this diagram, once we cover, we will almost sort of come out like an expert into Apache Spark. If you get this part, this is going to be really, really interesting. I will cover a lot of concepts in the same diagram. Okay, now let's see what we're going to do with this. First thing first, when I'm working on my Apache Spark systems, I have to, let's say, do some operation. My operation is, let's say, I want to make this all F1, F2, F3 as, let's say, uppercase. Simple operation. I want to do like that. Now, in order to do that, what will be my first step? My first step would be I have to bring this file F1, F2, F3 into my memory, right? Because in MapReduce also we were doing the same. In MapReduce also, if my data is sitting into my SDFS and I want to do any operation, let's say of mapper or something, I have to bring it to the RAM. Now, how I will do it in Apache Spark? In Apache Spark, this is my master machine. And in this master machine, I will have a driver which is called as SC. For now, I will explain you this SC in detail later, but just to give you some reference for now, this Spark context is going to be like a starting point for any application. This is going to be available with you basically as soon as Spark is already available and installed with you. So that is something which will be available for that. So let me quickly note down a code for you here so that you get an idea what we are going to do in this case. So the first code, in fact, let me go to the next. Okay, here. So what I'm going to do here, I'm going to say sc dot text file. I will explain you what this code do. Text file f dot txt. Let's edit this. Now what's going to happen with this file? As soon as I will execute this code, what's going to happen at the back? SC is my Spark context, which is going to start my application of Apache Spark. What this text file is going to do for me, this will go and look for this file f.txt in my HDFS location for now, though it can look at other locations, but I will come back to it later. It will go and search this file at HDFS location. So let's go back here. So yes, it will get this. It will say that, hey, this is sitting at F1, F2, F3 in these 3 data nodes, which belongs to file F. So now what it will do, it will load them into my memory. So it will bring F1 here, F2 here, F3 here. People who already know Apache Spark, please have some patience, because I know you might be thinking about lazy evaluation and all that right now, but hold on for that. I will slowly come to this because I want to make sure that first everybody understand what is this. Now, so you are saying that F1, F2, F3 is loaded into my RAM. This is what exactly this command is going to do for me. So I'm going to say sc.text file is equal, basically this f.txt. Let's save it by some name. Let's call it as, let's say, Shivang. Okay. Now, what is all this? So again, repeating what this command is going to do for you. Spark context is a master to start any application. Then I'm saying that text file, what this command is going to do for me, it will go and search for this file f.txt in my HDFS. Once it gets it, it will load it to the RAM. Simple thing for now. Now, what's gonna happen here? If I come back here and look at this, what is happening is this F1, this F2, or this F3, which we have just created right now, all these 3 together is going to be called as my RDD. Now, what do you mean by RDD? RDD means resilient distributed data. If you look at this right now, is this my distributed data sitting in RAM? Yes, it is a distributed data. What do you mean by resilient? Resilient in English terms, it means fault tolerance. Fault tolerance. Now, what do you mean by fault tolerance? Means my data will not be lost. But there is a problem here. If you look at this, what I have just done here, this data is sitting in my RAM, and we already know that any data which is sitting in RAM is not safe, because if my machine is down, I will lose everything. For example, if this machine is gone, I lose F3 immediately from it. So how do we deal with this now? So remember, what's going to happen is we also have the replications available here, right? So here I will have, let's say, replica copy of F2 sitting here, replica copy of F3 sitting here, and replica copy of F1 sitting here. Now in this case, what's going to happen? Let's say if this machine is down, so I lost F3. Spark will automatically go and check where my F3 is present. It will get a copy. It will load this copy into this RAM. So now my F2 and F3 together are sitting into my RAM right now. They both are sitting into my RAM. And that's why what will happen now, you can do the whatever operations I'm going to explain after that. We will do that operation on this. We will do, sorry, this is F3, right? Sorry, F3. Even on F3, we will also do the operation here. And thus we will be not losing any RDD data. Now in this example, this F1, F2, and F3 will become your RDD. And we have given the name of this RDD in the last example as Shiba. So this way, it is also going to be fault tolerant. I'm still not finished with this. I will also explain you when we do some operation, then it is how it's going to be fault tolerant. Hold on for that. But first level, let's talk about first step first. Is everyone clear about, first of all, what do you mean by RTD? I have not yet explained you anything in Apache Spark yet. I just started with the very basic steps. So I'm just explaining you what is RTD at the moment and what is the full form of it and how this is going to be fault tolerant as given in this name. Any question on this first part?
No.
Clear? Perfect. Now, let me draw this diagram once again. I draw my triangle. Also, F1 was sitting here, F2 was sitting here, F3 was sitting here. I loaded this into RAM, I loaded this into RAM, I loaded this into RAM. And this is where my Spark context is sitting. Okay. Now, look at this. Let's say I ran another statement after this. So I created this RDD name as Shiva, which was my F1, F2, F3 sitting into my RAM. As the next step, what I'm going to do, I'm going to say, hey, let's take my RDD Shiva. Okay, that's my first step. I'm going to write something called as map function for now. I will explain you what it do in some time. Now what I'm going to do here, I am going to write some code. Okay, so here some code to make it uppercase. Okay, any code. It could be a Python code, Java code, Scala code. I have just written some code here. Though I have written in English, it doesn't mean it will be in English. It will be in actual code, but this is just for my explanation. Now what this is going to do, let's call this as upper. What is this going to do? So the first step here, it's saying that I'm working on my Shivang RDD. Now what is my Shivang RDD? Shivang RDD is F1, F2, F3, which is sitting here. So what I'm saying is, I'm saying map. What do you mean by map? Though I will come back to it later, but for now, just for an easy understanding, what this map will do, whatever code you are writing here, this code, whatever your code you are writing here, it will go ahead and help it to execute on this. Okay, it will go ahead and help you to execute on the Shivang RDD, which means if I have F1, F2, F3 here, as in this example, then on this F1, that code will run, on F2, this code will run, and on this F3, this code will also run. So now let's say on F1, it ran some code to get it converted to uppercase. Let's say I got my U1 from it. Now let's say I got my U2 from F2 and I got my U3 from F3. Okay, so let's say I got this, and all these three together now will be called again as an RDD, and the name of the RDD we have given it here as upper. Okay, so now in my memory, I have U1 also sitting, U2 also sitting, U3 also sitting along with F1, F2, F3. Because in my RAM, I could have multiple programs running together. Just like right now, I'm using Zoom, which is also taking some space into my RAM. I'm also using some device, for which I'm using the whiteboard. This is also eating some space into my RAM. I'm running some browser where I am also showing you all this, basically this lab activities, that is also eating some space in RAM. So it's not like my RAM will only have one process at a time. It could have multiple processes and the data at a time. Same thing is happening here. My F1 and U1 can together sit into the RAM. Similarly, my F2 and U2 can together sit into the RAM, and my F3 and U3 can together sit into the RAM at the moment. Now, in this case, what is going to happen is this, whatever RDD we have created, what if this machine is lost? Maybe this last third machine is lost. Now, how this is going to be resilient? So recall, because we have replication, maybe my F3 copy was here, right? But I don't have this copy of U3 right now. I can bring my F3 from this machine to memory. Now, once I have this F3 here, can I bring my U3? Can I compute from F3 to U3 or not? Yes, we can do that. So that way we will be able to recover my F3 in case if this machine is lost as well. So not only F3, but also U3, we were also able to recover from it in this way. So this whole thing which we have done here is basically what we have done to make basically from to make it basically resilient here. So this is what U1, U2, U3 we created just like an RDD, and they're also sitting into my RAM very simply at the moment. Now, one more thing which I'm also going to do now. Let's say I'm going to say maybe filter. Okay, I'm going to run it on my upper RDD now. I'm going to write, let's say again, a map function only, and I'm going to say, hey, I want only the rows which is starting with, let's say, capital I. I am not interested in anything else. So I'm going to say a code to get rows starting with capital I. Okay, let's say I wrote this. Now, in this case, what's going to happen on my upper RTD, which is U1, U2, U3, it is going to go ahead and execute a code, and that will return only the rows which is starting with capital I. So let's say that we create from U1 F1, from U2 it will, let's not call it as F1, FI1, let's say FI1, which is filter RTD, FI2, let's call this as FI3. Okay, so these are the 3 steps what we have performed right now, and we again created another RTD called as FI1, FI2, FI3 right now in front of us. Notice one interesting thing what we are doing right now. What we are doing here is every operation what we are doing, we are not bringing the data back to the hard disk at all. Means first time we did an input output, but after that all these things are sticking into my RAM itself. Thus we are avoiding any sort of input output in this case, because every operation is going to be completely into my memory itself. And that's one of the strong reason, though I have still not completed the Apache Spark. I have to still talk a lot on this diagram, but I'm leaving you with a thought right now that you can see here why my Apache Spark is going to be faster in this case in comparison to my MapReduce. But can you also notice one thing here, that since I'm keeping everything into my RAM, one of the challenges, RAM is expensive. And since RAM is going to be expensive and you have to keep so much of data into the RAM, definitely it will have a big issue around it in terms of the costing perspective. So if you are working on in-memory computation, definitely your costing of your project will increase because you have to utilize or put more RAM. But when you have to bring hard disk, in fact, you can think of, right, if you go and just look at Amazon.in and search for a hard disk, maybe of 1 terabyte or 2 terabyte or 10 terabyte, it will be very, very cheap. But if you go and look at even 8 GB of RAM, which maybe you want to buy and protect, it will be expensive. So RAM is still expensive in comparison to this. So now whenever your project require a good performance for this perspective, then Apache Spark suits really well for that. And let's say you don't have a budget constraints for them. Now, in case if your projects do not require the basically extensive operation, just to give you an example, in Facebook itself, I can give you. So in Facebook, you might have seen that you run an app. Let's say in a Facebook, you are running this on a Facebook app. You might have seen that as soon as you log in, it starts showing you feeds, right? Now within those feeds, in middle, somewhere, can you notice there will be a bar and it will show friends recommendations. It will show you all your friends and will start showing you that, and you can scroll it like this left side, right? You can keep moving it like this. So that way what will happen, it will be sort of showing you all your friends recommendations like this. And maybe you can choose that if you find somebody useful, you can add them up. But tell me one thing, is it a very critical feature for Facebook? Which means when you log in, do you expect that if Facebook should show me immediately friends recommendation? Do you expect that? No, right? You don't expect that. You are expecting to view the feeds, but not interested in looking at the friends recommendation here. It is an extra feature what you get. So for doing this, that's the reason what happens. Even when you log in, it do not show you immediately. In fact, at the back, it can keep doing its computation. It will keep computing your friend's recommendation, maybe some new recommendation it want to give. And based on that, whenever it have completed its activity of friend's recommendation or computation, it can show you easily. Then, given this friends recommendation is a very big task for them, because internally there are so many nodes which works to show you as a friend and so on. It's a very complex, goes through the huge data. For that, they have a cluster. Now, in that cluster, basically, since they're keeping a separate cluster just to perform this friends recommendation, what's the point of installing Apache Spark on this? Because they really don't need it to be very fast in this case, and they can easily do this computation using a MapReduce code itself. That will be much cheaper for this operation and can easily basically return the result whenever it's done, and you can show it at that particular time stamp. So in those cases, MapReduce programming is not yet gone. If you recall on my day one, when I made this statement that 20% of the projects are still in your MapReduce, while 80% of the project have moved to your Apache Spark. Now this is the answer for it, because your costing also matters across. So you have to take that call diligently, that which one really mattered for you. Are you looking for a better performance, not bothered about the cost? Go with Apache Spark. If are you basically, if you think that there is some internal computation which is really heavy in nature, for which you need big data systems, but at the same time you're okay to sort of have some time spent on that, because that's not really critical, because it's for some internal computations, or maybe for the end user it's not very critical thing. You can simply run your MapReduce code for it. So that's one thing you have to keep in mind while coming up with your project solutions. Everyone clear on this part first? And remember, I'm still not done with this diagram. I will come back to it. But everyone got this idea or the answer for this component now? How to take these calls? Any questions? No? Okay. Now, coming back to this. Now, there are a few more things in the same diagram. First thing first, right now, what is happening? We created an RDD, which was for my first one. Where is that code there? Yeah, here it is. I created the first RDD called as Shivang. Let's come back to this. So this was my first RDD, Shivang. From Shivang RDD, I created another RDD called as Upper, right? Let's go back. So I'm saying from Shivang RDD, I created Upper. So as soon as I say Shivang RDD, it means that Shivang means F1, F2, F3 setting into RAM. As soon as I say upper RDD, it means F1, U1, U2, U3 into RAM. From this upper RDD, I created the third one, which was my filter RDD. What I mean to say, let me write it down here. I have a Shivang RDD. The Shivang RDD have created upper RDD. This upper RDD have created filter RDD. You can see there is a dependency chain which we have created. Even Shivang got created with the help of f.txt file. Okay, so this is also created using this. So here what is happening, from one form of RDD, we are creating another form of RDD. This operation is called as transformation operation. What I mean by that, as soon as you create a new RDD with the help of old RDD, we call this as transformation step. Now, similarly, from upper RDD, you created a filter RDD. So this step is also going to be called the transformation step. Okay. So this is some terminologies which you should be aware of. That what is transformation? Creation of new RDD from an existing RDD. That is what is called as transformation. Now, one more interesting thing here. If you look at this right now, to the end user who is running all these commands, he have not got back any result because these are all sitting into my RAM. Let's say I want to see the output of my filter, this filter output. I want to see that. This filter is nothing but FI1, FI2, FI3 sitting into my RAM. It's not yet printed in front of the user. How I can print it? So just like in your Java or in your Python, you have statements like print, right? In Python, you have print. In Java, you have system.println, right? So system.out.println. So you provide all these statements to print some variable. Similarly, here you want to print an RDD itself, right? This RDD also have some data. So the way you will be printing this up, you will say filter, which is the name of this RDD, filter dot collect. What this collect will do for you, this collect is going to print out this value of filter like FI1, FI2, FI3 in front of you. Okay. So this step, whenever you are outputting a result to the end user, this is called as action. Okay. So this is called as action. So when you are transforming one form of the RDD to another form of RDD, we were calling it as transformation step. Whenever we are printing something to the end user, outputting something to the end user, we call it as action. Now, definitely there are a lot many actions other than collect. Collect is just one action. We will talk about them. Right now, we are just understanding this concept. So I just took this example. So collect will return all the records present in your FI1, FI2, FI3. Now, any question till this point? What is a transformation? What is an action? Everyone clear on this part first? Yeah, Harshal, you were saying something? Okay. Now, one more thing is
Sure.
this. Yeah, please ask.
Question. So Spark context is just an utility that helps us in creating an RDD. Is that right?
Yes. Just like in Java, if you are writing a code, you always start with the main function, right? Without the main function, can you write a Java code? No, right? Same way, think of a Spark application starting with a Spark context.
Okay.
I will actually change it a bit when I move forward. There is something called a Spark session, which I will introduce you later, which have embedded this Spark context. But for now, since we're just understanding this up, I'm just starting with Spark context as a starter of your application. Now, so we understood this first component, what is an action and what is a transformation. Now this graph, which we have generated here, we call it as directed acyclic graph, or in the Apache Spark word, we also call it as lineage. Now what's the use of this graph? Let's understand that. So whenever, in fact, let me get back to this diagram. If you look at this diagram, what we are doing here, we added from F1 to RAM, then from F1 I created U1, then from U1 I created F5 U1. Similar way, I could have another application running on it, which could be, let's say, another file, let's say X1. From X1 I generated maybe first X1, then after that maybe second X1, and so on. Similarly here, maybe I have X2, here I put down my FX2, then I created SX2 and so on, right? So if you look at this, maybe I have multiple applications and all of these applications will be also putting their RDDs onto the RAM. Now, are we even using these right now into my RAM? No, because until and unless I hit an action, means when I want to, until and unless I really want to show some results to my end user, all this data is just sitting into the RAM. So this way, if we are doing it, what exactly is happening right now is that my lot of memory is getting wasted here. Lot of my memory is getting wasted because I'm not even using them up right now. It's all just sitting into the RAM and just wasting up my RAM right now. And RAM is very expensive. We already learned it. So what we should do in this case? So a better approach is that how about what Apache Spark in fact said is that until and unless you hit an action, it will not bring any data to your RAM. Means when you are doing your transformation steps, there will be no data which is going to come inside your RAM. What does this mean now? So let's understand it again with the help of this diagram. Okay, so what it will happen as a first step. So let's say, let me draw the RAM also here. So what is going to happen as the first step? My first step would be, let's say you said, I have a file F1, F2, F3, and you hit your first statement, Shivang is equal to sc.text file f.txt. What it will do immediately, it will start creating a lineage into the master machine, basically, which will be with the Spark context. And it will say, hey, I have a f.txt file, and this f.txt file should create Shivang for me. Okay, but right now, no data will be going into my RAM at this moment. There will be no data inside it. This is just going to create this lineage for me at the moment. Now, what is the next step? Next step, you said upper is equal to Shivang.map, then some code which is going to convert my lowercase to uppercase. Now, what it will do, it will say, hey, I'm going to create an uppercase RDD for you. But right now, since F1, F2, F3 is also not present in my RAM, so I will also not place you also in my RAM. I'm just going to keep it like this. My memory structure will exactly look like that. Okay. But it has just created a space into the lineage right now. Now what's going to happen after that? It will say, hey, I want to do a filter operation. I want to create a filter RDD which start with capital N. It will again just place this into my lineage right now, and nothing will happen into my RAM actually. Now what you did, you said, hey, go ahead and say filter.collect. Filter.collect. You executed it. Now what's going to happen? As soon as it will say filter.collect, it will ask filter, give me the data. Filter will say, I don't have any data. Filter will go and say, hey, upper, give me the data. Upper will say, I don't have any data right now. Upper will say that, hey, Shivang, give me the data. Shivang will say, I don't have any data with me. Now Shivang will go and start loading the data from f.txt. Now it will bring this F1 into the RAM, F2 into the RAM, F3 into the RAM. Now Shivang got the data. Now Shivang knows that I have to execute the upper RDD. So now it will say that, hey, go ahead and execute this. So it will create U1, U2, U3 for me. Now this will say, hey, go ahead and compute this for me now. So now it will say Fi1, Fi2, Fi3 into my RAM. Once it will complete it, it will return the result to the end user. It will print it. And then after that, it will again go and remove all these entries from the RAM. This is the default behavior of your Apache Spark. Yes, we can do some tweaks and changes for optimizations later, but we will see them at the later point of time. Maybe that will come tomorrow or on Monday. But for now, this is the default nature. As soon as it returns the result, means as soon as it returns the end output, or we completed the action result, then after that, all the data will go ahead and get flat. It will remove itself as well. So it don't keep the data into RAM for a longer period this way. It is ensuring that we are not unnecessarily wasting the space into the RAM. So what we have done here, we just said until and unless you hit any action, no data will come inside my RAM. It will stick wherever it is. And once the action step is given, it will start performing, looking at the data from the lineage. Your DAG will be returning up the results for you. And basically it will start computing and give you the result and again remove all the data from the RAM. So this concept is also called as lazy evaluation. Now, one important thing, this lazy evaluation also have a lot of advantages. This will come in your second half. I just told you one advantage right now, which is okay, fine advantage, but there is a major advantage of lazy evaluation, which I will explain you in the second half that how exactly it looks like. First of all, everyone clear with this?
Quick question, Shivang. So let's say we created 3 RDDs, and after that we try. So according to the graph, like, and we collect and we invoke the collect, right? So at that time, all these RDDs will actually be created, right? So will all the 3 RDDs will be present at the time of collect, or will like each one be overwriting the other one, or at the time of collection, all the 3 RDDs will be present in the RAM?
Okay, let me ask you one by one. So you're saying that you have this lineage and you said upper dot collect. Am I right?
No, I'm still talking about filter dot collect. So
okay.
So at this point, like three RDDs will be created, right?
RDDs will be created into the RAM. You got the result. It will remove it. Fine. The first step is done. Now you are saying that again hit filter dot collect.
No. I'm talking about the first time. So so right now I just hit when I hit say filter dot collect, 3 RDDs will be created, right? So in the process of creation of these 3 RDDs, will 3 physical RDDs should be present on the RAM, or is upper overwriting Shivang and filter overwriting upper?
No, all the 3 RDDs will go into the RAM. So first of all, this RDD is immutable. Okay, so it's not like it will keep overriding and keep removing F1. Till the time FI1, FI2, FI3 is not returned, F1 and U1 will also stay inside the RAM. It's not overriding. This data will stay inside my RAM.
Okay. So at the time of when I said filter dot collect, I'll get the filter RDD, like the F1 FI RDD. At the same time, if I say upper dot collect, I'll also get U2. Is that a U1? I mean, the second RDD. Is that right?
Yeah. Let me explain you what's going to happen in this case. So first you said, let's say filter dot collect. It gives you the result of FI1, FI2, FI3. It will remove all this. Next time you said upper dot collect. Now what's going to happen? It will load F1 from here, F2 from here, F3 from here. It will create U1 from here, U2 from here, U3 from here. It will return the result of U1, U2, U3, and then it will remove these two. So in this case, your FI1, FI2, FI3 will not be created.
Got it. So it's going to do the whole process again. Got it.
It will do again. This is the default nature around. We will also see how we will fix it, how we can optimize it. As you can clearly see, it could have an optimization impact. Maybe I need to re-execute it multiple times, right? Then I have to recompute. That is not a good situation everywhere. So there are optimization things, which I will also teach you. That will come, like I said, in a later part of the class.
Okay.
Any other question? Amani, you were asking something? I think you unmuted at that time. Everyone clear with this, or anyone have any question on this? Perfect. So we are clear with this part of the example. So as you can see in this example itself, we not only understood how Apache Spark works, we understood action, transformation, lazy evaluation, and multiple concepts within the same diagram. I will keep bringing this diagram quite often. But for now, let's quickly go back and see few things in the form of code as well, because whatever we have done, let's see whether it works also or not. That's going to be important for us. Now, in this particular case, what I'm going to do, let me come out of this HBase. I just came out of it. Now, let me show you how we work with this. So if I type spark hyphen shell, let's see what's going to happen. Okay, first of all, what's going to happen with this? When I connect it with Spark hyphen shell, this is the shell where you can write your Apache Spark code using Scala programming language. Okay, you can see here it's telling you that my Scala version is 2.11.12. You can also see that this is using a Spark version of 2.4.0 here. You can also see one more interesting thing, which is telling me that the Spark context is available as SC, which means when you connect to your Spark environment, this Spark context is by default available for you. Okay, when you will not be writing in this shell, but maybe in a Eclipse program, then you have to create it. I will also show you that later. But for now, this is something to keep in mind, that this is by default available for you. Now, this is for your Spark shell. Let's come out of it. Now, let's say I want to hit this PySpark. Let's see what this is going to do for me. This means I am going to write my Apache Spark code using Python programming language. So this is for Python programming language. If you want to write the code, they can do it by using PySpark. Let this get connected. You can see here. And here also you can see that I have basically all these things like Spark 2.40. And you can see here it's showing Spark session available as Spark. I will tell you what is this. Basically Spark session, inside that I have Spark context available, but more on that later. Okay, so we will see to that part as well. But right now I can write my Python code or I can write my Spark code using Python. There is no such shell available for us. There is no such shell available in Java. For Java, you have to write all this code basically within your Java code and then run it with a Spark submit query, which I will explain to you later. But these are the two ways I can write basically my code in the shell itself. So let me again go back to my Spark shell. Now, in order to do this, let me also quickly bring up a file from SDFS. Let me see if I already have a file here. Let's see this file. Okay, you can see I have a file called as test.hadoop. Oh, sorry, test.txt. Now here /user/Lakshmi1706 is my location. Let this get connected. We have to wait for it. I don't know why it's taking so much of time. I hope it's not due to the fact that I closed it, but no, that should not impact. Okay, anyway, let it connect. I think something is really wrong. It sort of got stuck. Okay, let me close this and reconnect again. If it do not work, I have this in my Cloudera machine also, but it should work ideally. Let's hope this time it will go in. So what I will be doing in this exercise, just kind of giving in context. So what I will be doing here would be, I will be connecting with this, will be loading this file and should be able to print it out. Okay, so I will be creating an RDD out of it and should be able to print it out. That's going to be the thing which I'm going to perform right now with this, but it's surprisingly just taking some more time. Let me see if in the Hue itself they have enabled the Spark. We can, but they have not enabled it that well. Fine. Let's wait for some minutes. Guys, if you're also trying to connect along with me, please hold on, because otherwise it may end up taking more time because we are all trying to do it together. Please close the shell in that case. Let me also do one more thing meanwhile. You have to wait for it. They've not enabled it. Okay, I'm sorry, I was talking on mute. Yeah, I was saying that meanwhile, can you all quickly go and try at your end also? I'm just meanwhile opening my other machine also in case if it do not get stuck, at least we can have no impact on the lab because it have already taken more than 2-3 minutes. I suspecting there is something wrong. So I will be talking with the Cloud Lab team during the break time. But meanwhile, can everybody go and check on this that whether this is sort of working for you or also not? Means I just
It's
want to see
working
whether
for me, Shiva.
it's working. Okay. So you
Yeah,
guys
me
can
too.
working for you also, Karthik?
Yes, yes.
Okay. So you guys can connect with that in that case. I will just use my own lab. I will get my account fixed. I don't know why it's taking so much time. It's weird actually. So all of you can get connected to your Spark shell. We will be doing some labs now.
Shivan, initially it got connected for me. Then again I exited, and then after again I am trying to reconnect. It is showing some error, connection refused or something.
Yeah, same with me.
Okay, so once you get connected, please don't disconnect because that's the same thing which just happened with me. Just that I didn't get any error, but you can see it's taking a lot of time. There is something weird in the cloud. Maybe there is some process which is interfering with this. Anyway, let this open. Even Apache Spark is so simple that if you have a Linux or Mac systems, you can even have this set up on your local machine as well and can work on it. So you don't need really SDFS for it. Okay. Anyway, let my machine open. It have already taken about 5 minutes. So meanwhile, this is opening up. Let me just, what is this? Okay, then this.
Shivan, are you there?
I think he got disconnected.
Okay, is Lakshmi here? Lakshmi also got disconnected. Okay, let me call Lakshmi. Wait.
He told he will restart his system.
Yeah, okay, Adit. Even I checked with Lakshmi. He tried calling Lakshmi. So we'll wait for like a few minutes. He should be back. Meanwhile, Lakshmi, facing the same issue with that queue, I'm not able to open. Can you just help me with that?
Hello, Girish.
Hello.
Yeah, Girish. So I was saying that we probably
Uh-huh.
we can break for lunch now and connect back at 1:30.
Okay, wait,
By the
Kelvi.
time.
I'm getting call from Lakshmi.
Okay.
Yeah, hi, Lakshmi. Yeah, hi Surbi, we can go on break now. I think his system got frozen completely, Shivang, so he should be back. So
Yeah.
we will assemble back at maybe 1:45.
Hey guys,
Wha-
Oh,
I'm
you are
already
in.
back.
Oh, okay.
It's just that my system, I don't know what just happened. It's this
Yeah, yeah.
lab is as
We got
well.
to know from Lakshmi. So we were just thinking, like, should we go on for break now, or we'll continue, Shivang?
We can continue. I'm just
Okay.
connecting the lab quickly. It should be okay.
Okay, Shivang. Yeah.
Lakshmi, you have to give me the access to share my screen. Lakshmi. Okay, meanwhile, let me connect to my lab. Yeah, Lakshmi, can you give me the host access? I'm not able to share my screen. Yeah.
Yes, so there are two things. So to RP labs part, I just
Okay, let me get connected with the lab. Let me see if she had given me the host access. Not yet. Okay, let me share my screen. Lakshmi, I still cannot share my screen.
Check now, Shivang.
Yeah, I cannot still.
Girish, first let's test it, okay, and then we can go for a break.
What do you mean by testing? Can you just give me the processes? We have still a lot of things to talk. We
Okay,
can, yeah, we can do that without lab also.
okay, fantastic. Yeah.
Okay, so meanwhile they're fixing it. I got the problem also why this is happening, and they have to fix it up. So guys, I think few of you are using the same account as me. Okay, please don't do that, because what's gonna happen is, like, from the same account as if I'm opening a Spark shell, and if you will also open the Spark shell from the same account, it is bound to clash. So you already have your own accounts. Please do that, because I can see here that few of you are using the same account, and that's an error which I was able to retrieve, that this is already being in use. Okay. So since it's already being in use, it will anyway not be able to connect. Only one instance get connected at a time. So whoever is using it, please stop it. Meanwhile, I've already asked the Lakshmi to get this fixed as well from her end. So let her do it. Meanwhile, let me explain you some more concepts which basically are required. And maybe after the lunch time, we will have basically this lab back and we can start working over it. So let me just open this so that I can explain you some concepts meanwhile. Okay. All of you can see my screen, right? On this? Perfect.
Yeah, Shivanku. Yeah, I can see your screen.
Now, first thing first, in Apache Spark, there is something called as val. So let's say if I say val a is equal to 10. Okay. Now what does this mean? This means I am creating a variable a which assigned a value 10 to it. And this is a val type. Notice I'm nowhere telling it's an integer or it's a string or it's any other thing. I'm nowhere telling it. What Scala will do, Scala will automatically interpret it as an integer. That's the first thing. It will automatically interpret it. Now what's going to happen with this? So since I got this value is equal to 10, I've assigned this. So now let's say if I say a is equal to 20. Now in this case, I will get an error. Why? Because whenever you are assigning a variable as val, then it is going to be called as a constant. When I say constant, it's like a final variable in Java. People who are coming from Java background means it's a fixed value. You cannot change it after once you have defined it. So you cannot change this value at all if you have basically defined something as val already. Okay, it's a constant. On the other hand, we have another thing called as var. They can say var b is equal to, let's say, 20. Now, in this case, if you change b is equal to 30, it will happen. There will be no error. Var means variable. Okay, it is not a constant. You can change it. It will automatically interpret that b is an integer, and then you can keep changing it. But if you try to do b is equal to, let's say, Shivam, you will get an error. Why? Because if you have already assigned b as an integer, then you cannot change this completely at all. So this is not allowed. So since it's already an integer, you cannot change this part. Now, if you want to still change it, you can say var b is equal to Shiva. This is going to redefine it. But if you just define it by b is equal to this, it will not work for you. Clear on this part? The difference between val and var? Okay. Can you quickly connect with your Spark shell and try this part quickly? In your Spark shell, you will be able to create all your Scala commands as well. So can you do that first? I will keep showing you here for now. And as soon as the lab is ready, I will come back to it.
So Shivang, I am facing same problem. I got disconnected. I am not able to connect with Spark Shell.
You're not able to connect to Spark shell. Let me give you a solution, a quick solution for it. 1 second. Because we are anyway just doing Scala right now. Okay, can you all do this meanwhile? Whoever is facing this issue like me, just execute a code here. I'm giving you this link. Okay, you can execute all your things. And it just that it will take a little slight more time. I know about this, but at least something is better than nothing for a few minutes, at least before the lunch part. I just gave you this link. What you have to go do is come to the standard in and start writing your code here. And then once you're done, you can just click on this execute. And once you will execute this command, this will give you the result on the right hand side as well. In fact, you can do this here also. You can come here and whatever I'm teaching you, like you can remove this from here and you can also execute it here as well. Like you can define your var a is equal to, let's say 10. Okay. And then you can define your next set of statements as well. Here the semicolons are not required. We can say print of A. This will also be fine. We can execute the codes in this file as well. I'm completely fine with whatever way you want to. Okay. Only thing is this will, you can see I'm getting this 10, right? So this is how you can also work. So whatever code I'm explaining, I have not yet explained you what is an object, what is the main function yet, but inside the main function, you can come in and write your code, whatever I'm teaching you. Yeah. For people who can work on a Spark shell, please use that. For people who are not able to use Spark shell, please use whatever I'm showing you right now. Now, can you try these statements? Try with var and val. Try to change the data type with var also. See if it's working or not. Once you're done, just type done for me. Meanwhile, let me just see this error, if they fixed it or not.
So Shivank, these errors when we try to connect the Spark shell, I think only 16 people can join because it is saying like there are only 16 ports and all are taken.
Okay, Lakshmi, can you get this fixed?
Yeah, and also team, can you parallelly like try to open the Spark on your VMware? Sorry, not VMware, VirtualBox.
No, that is what is happening is if I keep the lab open along with my lab, it will hang my machine. That just happened before.
Okay.
So I want this lab to be as a more high priority for now. That's the reason I don't want to again get hanged.
Okay. Okay.
It will anyway fix. It's a very simple thing. They have to just change the configuration. It will start working.
Okay. Because multiple people are using the same lab and they might be opening the Spark shell at the same time. If this port number is being said, then we might end up into this problem, right? I'm just thinking.
Okay. Let me just still see. I'm also trying to see if I can fix this error from my side itself. Meanwhile, can you guys quickly try this out? If once you're done, just let me know. Let me also try to kill this process at 4041. Might help fixing this issue. It's 4041, right? Guys, you can keep doing that problem which I gave you. I'm just trying to fix this for a minute. 4040. it's not letting me see the port also because I'm not a pseudo user. Anyway, let the cloud team fix it. All of you have tried this? Now, one more thing, guys. Before we go on a break, let me just talk about one more thing. Just listen to me. You can try this maybe during the break time also. And we will get the lab fix also. So if required, maybe we can extend the class by a few more minutes other than 4:15. We can add up some minutes just to see, because I also have some plan ready for today's session, how much I want to finish. If that is not over, maybe we will extend by just few more minutes, 5-10 minutes, whatever we are losing right now. Now, one more thing which we can also do is, though when I define it like val a is equal to 10, it automatically determine my data type. But it's not mandatory that I want scalar to do that. Maybe I want to define it on my own. So I can say val a, and I can define what is the data type I want. I can say integer is equal to 10. So this is also fine. I can define the data type of my wish as well. So similar way, I can say val maybe b, let's say this is a Boolean data type. I can also define it like this. So I can either be explicit or I can just leave it to Apache scalar to take care of it. Similarly, if I want to say, let's say a character value I want to define, so maybe I can say char, maybe whatever character, right? I can define it like that. If I want to define, let's say double, I can say D, maybe double, and I can define, let's say 3.14, whatever. I want to write whatever, I can do that. If you want to define, let's say float, you can say, let's say here as a float. And once you define it as float, say 3.142F. Otherwise, by default, it takes it like a double only. So you have to kind of tell it that it's a F format for you. One more thing, let's say I say val X. This time I want to define it, let's say as long data type, which is like bigger than your integer. Then in that case, you have to say it like, say 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever you want to keep till whatever point, but put a L after that. Otherwise, you will still get an error. By default, even if you have defined something as a long and you don't put a L in the last, it will still be thinking that it's an integer and it will be kind of giving you an error in that case. So keep in mind that how you will be defining all these values as well. Everyone clear on this part?
Sure.
Okay. So maybe you can try this also during the break time, or maybe once you're back, you can try that in 2 minutes. Let's go for a break now. Like I said, today class is already an extended class a bit. Maybe it might get extended by 5-10 more minutes, depending on if we are not able to finish what is planned for today. I hope everyone is okay with that, because we have already kind of wasted some 10 minutes or so during the lab activity. Okay. Sure. So then let's connect at 2. Meanwhile, let me just connect with the lab team and quickly try to fix this issue. Okay. Sure. Thank you.
Thank you.
Thank you.
Okay, is everyone back now? Is everyone back? If you guys can confirm. Also, the lab is fixed now. Can you go and check if you're able to connect? If not, let me know right away. Can you all go and check that? I can see some 7-8 people are missing also. So if anybody is not able to connect, please let me know right away.
Oh, Shivang, it has to be Spark Shell or PySpark?
Spark Shell. I will be using Spark Shell only.
Okay, okay.
So all of you just quickly go and check whether your Spark-shell is letting you to connect or not. If in case the problem still persists, I have Lakshmi with me. She will be able to assist you quickly on this.
I can connect. Sure.
Okay.
That's working.
Perfect. Perfect.
It's all good. It's not working.
Okay, perfect. So looks like for everyone it's connecting. Lakshmi, maybe you can stay back for a few minutes. Just let's not everyone is in the class. Maybe in case if somebody else faces issue during the lab, we can get back.
Girish, can you call others also to join the session?
Girish, can you check on that?
Girish Gurjala, yeah.
Yeah, hi, Lakshmi. Sorry, I did not hear you properly.
Yeah,
please check the others to join the session.
I think we have 27 participants. Yeah, I think people are joining. I think we can start, Sivank.
Okay.
Yeah.
Lakshmi, I'm still getting that warning message attempting ports 40, 41 starting with ending with 40.
While using this Spark Shell?
Yeah.
Okay, fine. Let me check. Others who are facing this issue.
Yeah, Lakshmi.
Just you can put it in the chat window. Yeah, Srivatsa also.
Yes.
Maybe whoever is facing issue in the chat window, give your login account to her because she can provide the same to the lab's team and they can fix it.
Lakshmi, I am also facing the same issue.
Gayatri, okay.
Yeah, me too.
Having this issue?
Yeah, I'm having the same issue. Yeah.
Okay.
Just provide your email ID or whatever your login credentials are.
So Shivank, I don't want to hamper the session. You start with the session. Others, please put it in the chat window. I'll take care of it.
Yes, perfect. So let's start again on the things which we have done. So I already explained you some portion of var and val, and now we are connected with our Apache Spark session. Let's do some activity on top of it. So let me quickly show you first of all this code which I had just explained you up. So let's say I'm going to say val. Now we have already understood what this val is going to do for me. I'm going to create this RDD as Shivank. Okay. And what I'm going to do with this is I'm going to say sc.text file. So I'm just defining basically my text file being provided here, which is going to basically return the values for it. Now let me quickly go to my Hue to just see that what is my file address along with me. Let us get connected. Okay, let's go to the files and we can see it now here. Okay, so this file which I'm going to pull up is going to be my test.txt file, which have some data. Okay, just the normal data which I have pulled up just to see that how it works right now. So what I'm going to do now, let me pull up this file. Usage user Lakshmi 1706. Let me give this path here /user /Laksh1706. Let me just quickly confirm if I'm giving the right spelling. LAKSH. Yes. And the file name is test.txt. Test.txt. Now here, when I'm executing this up, you can see here, I'm just giving this, and you can notice it is giving me an RDD of string data type. Okay, just allow me 1 minute. This lab people are calling me directly. Hey, hi, Prasanna. Yeah, I'm in a session, Prasanna. Is there anything? Okay. Sure, you can do that. I will share with the candidates. Sure. Sure, sure. Okay. Okay, for people, it's not working. The lab team is saying that they will just give a new command for you guys to connect. You can just try that and let me know. Once they share, I will share with all of you. Okay, coming back to this. So you can see here, it has created the RDD of string data type. And now if I want to see this result, I will say Shivang dot collect. And you can see here that this is going to run something like status and all. I will explain you what is the status also later. But for now, let it get executed. And this will return me the output. Okay, this is just a warning. This should not take this much time. If it is, then something is wrong. Has not accepted any resources. Let me just quickly check with them. Looks like something is wrong. Lakshmi, are you there?
Yes, Shivang, I'm here.
Can you please call and inform them that it's still not working?
Fine, I'm calling them.
Shiva, can this be done on a virtual machine?
Just 1 second. My virtual machine, that's what I just told you. It also have some problem. When I'm opening it, it's hanging my system. Okay, so it looks like it's again coming back to the same complaint. Initial job have not accepted any resource. Check your cluster UI to ensure that the worker are not registered or something. Looks like they have not given the resources. Let me just tell them very strictly that.
Yeah, done. I've already spoken to him. I'll just fix it and update you on this, Shivang.
Okay, I've already sent him even the screenshot.
Okay.
Yeah, so let me come out of this. So let us get connected once again. And for the people for whom this is having this error coming up, I'm just sending you one more command. Just try to see if this is at least working for you or not. Spark-shell-c spark.ui.code is equal to 11111. Yeah, just try this. Meanwhile, then I can do one thing. Let me close this lab and try to open my virtual machine. Otherwise, we will kill time on this. Now it will work basically. Okay. Meanwhile, till the time this machine is opening up and all, I want one thing from all of you for whom this is kind of working. Can you go ahead and the command which I have just executed for you, which is going to be the loading of the data file. And once the data file is loaded, then basically you have to just print it out using a fillet command. There should be very quick results with which it will return to you. Whoever is done, just let me know your result as well. Let me know once you're done, guys. After that, let's work on some more items here. Done? Oh, Lakshmi, there are two Lakshmi in the session. Okay, yeah, there's Lakshmi Boga. Fine.
She's a participant, Shivang.
Okay.
Shivang, I had a question while my lab is not working. I'm using Lakshmi's ID only. I don't have mine. So when you run this command, well, RDD name is equal to sc.text file and the path, what exactly happens in the backend?
Yeah, Lakshmi,
We still
that's the
don't.
reason.
Sorry?
Let me just listen to it. That's the reason my lab is not working. Because what is happening, you're trying to connect with the Lakshmi account, which I'm also using, and you're also using the same account. So
Yeah. So I did Control Z. I'm not trying anymore. I just tried with that port number 1111 and then I left it.
Okay, guys, it's a request. Anyway, I've opened my own machine, but it's a request. Please don't use the same machine which I'm using. Otherwise, it will conflict. If I will try to open two Spark contexts, it will not get the resources at all. So that will conflict with. Yeah, I
right.
can explain.
I'm not using it, but just one confirmation, which the port number which you gave us to try 1111. Are you also trying with the same port?
No, I'm not using the same port, but still on the same account, we cannot open two Spark sessions. It will conflict because this cloud do not have that much response. Yeah. So it doesn't
Okay.
matter even if you're
Anyways,
using
I'm not trying anymore. I'll just go through this later on when I have access. But my question was more around what exactly happens when we hit this command of sc.text file and then the path name. The file comes to my memory only when we run the collect statement, right?
Correct. That's what I explained you at that time, right?
Yeah.
So what will happen when you say sc.text file, sc.text file? Now with this, only you are giving a lineage for this. So let's say when you say this, it will just create a lineage for you. But when you will say, let's say you saved it by name S, when you say s.collect, then only this will get executed, which means it will load this f.txt to the RAM, and then it will return you the result which is present in that file.
Okay. And when we run any function, for example, filter upper or etc., that time it creates the function. It is more like creating a modular function, but not calling it, something like that, right?
So till the time you hit an action, nothing will happen.
Okay.
Okay? That's something basically what Spark follows. Now, let me just show you a few of the things meanwhile. So you can see here. In fact, let me ask one question here from all of you. So here we were able to s is equal to sc.txt file. We did this. Let's say f.txt exists. Now what I did, instead of f.txt, I gave, let's say, surbi.txt. And let's say surbi.txt does not exist into my SDFS. What will happen when I hit this command? It should throw an error or not?
File not found.
Hmm?
File
It will
not.
throw an error.
It will throw an error? Okay. It will not throw an error. Remember, I just answered the same thing, right? It is only going to create a reference. It is only going to create a lineage right now. It is not doing any type check for you. Since it's not doing any type check for you, that's the reason what's going to happen. It is not going to at all do any sort of check for you, and it will not throw any error. When you will get the error, you will only get the error when you will hit the statement.collect. So when you will hit the .collect statement, then only it will go back and say, hey, give me the data. Hey, give me the data. And once it will ask the data from this RDD, then it will try to search for surbi.txt. It will not get it. It will throw you the error. Clear on this part? If you want, for whoever the lab is working, you can try this also. And in fact, have you guys already from the IT team got the Cloudera access?
Yes, Shivam. We got the access for Cloudera.
So for you guys also the Cloudera VM is working? Awesome. If that
Yes, for me it is working.
Okay, then there is no hindrance on the lab. Okay, 1 second. Let me come back to my lab here. And I can show you that in this lab also, it will work in the exact same way, what we were seeing till now as well. So here you can connect in the same manner. So like I can come down to my terminal and I can hit spark-shell, and this will also work for me. Okay, so there will be no issue with this portion as well. It's just that it's a little older version of Spark, if I'm not wrong. Let me see what I have installed on it. But that will still be suffice for us for now. Okay, if you're using VM, that's great. So can you just try maybe on your VM in case if your lab is not working also? Can you let me know if you give a non-existing file, is it throwing you an error immediately or not? Quickly try that and let me know.
It is not giving error. When we do collect, it is giving error.
Yes. And can you tell me what's the error you got when you did this?
So the error is input path does not exist.
Input path does not exist. Correct. So if you go back, it's like a Java exception. If you go up and look at this error, it will say that, hey, input part does not exist, what you're trying to kind of add to it. So that's the problem which it will bring for you. Now, the next thing which I also want to kind of quickly bring up, let me again go back to my book. Yeah, so here you can see I'm getting connected to Spark anyway. And this is what I've also shown up here. You can see with PySpark, we will be getting connected to Python Spark, and here we will be getting connected to Spark Shell. Look at this one. So one thing in this book which you're seeing right now in front of you, basically the yellow color, if you notice any code, that's going to be a Python code. Any code which you see in the basically purple color, that is a Scala code. Okay. So at some places I have specifically mentioned it. At some places it will not be mentioned. So yellow color, just understand it's a Python code. So here you can see also that it will say that, okay, it's available as SC. And if you say sc.app name, this will basically tell you up that, okay, you have something called a Spark shell. Or if you say sc.app name in your Scala, then it will tell you that, okay, it's a Spark shell. So it's basically tells you that where are you connected right now. Now, basically, this is all about your RDD concept, which I've already explained you. Now look at this one. Here, this is the same one. You can see here, I'm using a file which is called as purplecow.txt. And in this purplecow.txt, I have some data. I'm saying that I have never seen a purple cow. I never hope to see one, but I can tell you anyhow, I did rather see than to be the one. Now, in this case, I loaded this my data as into my basically memory. And as soon as I hit this count, means then only this data will get loaded to my RAM. And similar to collect returns the output. Count, what it will do, it will return the total number of lines for you. So earlier, this purplecow.txt was just a file here. But as soon as you say that, hey, .count, it basically loaded this data to the RAM like this. And then it will return 1, 2, 3, 4. There are 4 lines in it, and you will get basically the output. So tell me, count is an action or a transformation?
Count is an action.
Count is an action. So that is something you all have to keep in mind. It is going to be an action here. Okay. Now, look at this one. So this is, I've already explained you, nothing to explain here. I will maybe keep on showing you some code. Similarly, here you have some more commands for it. For example, when you say collect return you by default all your output. This is kind of very important thing to understand. Collect returns all your output. But at the same time, if you do a collect, what it is doing at the back, it is returning out all the data to the driver node, okay? Because it's returning all the data. If your driver node do not have that much of memory, what your data is coming, in that case, it will be a problem. So because you may get out of memory errors or exceptions like that in that case. So if you're testing it, it's not a good idea to use collect at all. Instead, you should be using something called like a take command. What does take do? You can say in take, I want to return, let's say only 5 values. So you say your RDD name dot take. What this is going to do for you, this is going to return you only the values which you need. Like you, let's say you say 5, it will return you only 5 values. But collect will try to return all of it. Now, some places in Spark, they configured this collect to 20 so that it don't throw you all the errors. But it depends on the configurations being set up for Apache Spark in your cluster. So this is one thing you have to definitely keep in mind, that always use take command instead of collect. So take is also, it's also the same way how you have collect, but it's just that it can limit your number of records and you can quickly test it and that should be all fine. Let's come back to it. And here, what I'm going to do is, let me open my Spark shell is open now. Let me quickly see in my Hue browser. In my Hue browser, I should be having some files or something like that available. I can also check it from my SDFS as well. I can also say SDFS, DFS-ls, just to quickly see what all the files I have. Again, these are Hadoop commands. It will take their own sweet time. Yeah. So I have some files which I had done it or used it at the time when we were working earlier. So if I am not wrong, we had some data being present inside my trial directory also. You can check that. I just need a file which I can show you how it will work. And since these are Hadoop commands, these will take their own sweet time. You can't do anything about them. Let me also keep this open in parallel. And meanwhile, this is running. Let me just note down this command as well, which Shivang is equal to sc.file, and whatever file is coming up here, it will take this much of time like this. Let me do it with you only then. This much of time to open in view. In Cloudera, this is one of the big problem. It takes its own sweet time to open up, depending on how many resources you have, and you can't do anything about it. Okay, let this open up. Meanwhile, let me just come back to this. Okay. Can all of you quickly go ahead and create the same file which I just showed you here, which is, I have never seen a purple cow. I never hope to see one, but I can tell you anyhow that I would rather see than to be the one. Means not exactly the one, just make sure that the first initial letter, if it's starting with I, make it with I. If it's starting with capital B, make it with B, because I have some activities which I will ask you to do on it. Quickly create this file, upload it inside your SDFS. Let me know once you're done.
Shivam, can you just show the file once again?
Okay, sorry. I think I moved it out. Yeah, this one. Can you say this?
Thank you.
Have you all done that? Uploaded it in this? Just try to do sc.expire, do a count. You should see 4. How many of you are done with that? Yeah, text file is case sensitive. Oh, somebody have thrown an error. Okay, so we just make sure that give F as capital. You can see this command here also in front of you. This is scalar 1. Okay, perfect. Supreet. It's working fine with count also. For tomorrow class, I will install Spark on my machine itself so that I don't want all this things to happen at all. I didn't expect this actually at all. Okay, done guys on this part. Able to see the results? Perfect. Just leave it like that because we will be using this a lot in our session. This the file which I just explained you, I will be using this a lot. Now let's come back to a little bit on scalar because we have to quickly finish some scalar component and then we will get back to Apache Spark. The same file which I'm just showing you up, we will be using it up. But before that, you need to really understand some scalar component so that you can understand how to write that code in Scala and Python as well. Python anyway you can easily make out, but this is going to be important. Now one important thing, let's say if I have a string, let's say I created a var, and in this var I define a maybe a variable, let's say a, and in this a I'm going to define some basically character to it. Let's say I define it, let's say as hello. Okay. Now in this hello, I have my data being present and that is going to be the output right now. But what I want to do now is I want to append something. So maybe I want to say basically one more thing to it. I am going to say it as a plus word. If I want to concatenate like this, will it work? Let's see this. You can see it will work. So what it will do, I could have assigned it to some variable. That's something I can do. So if I want to change my string like this, you can change that, but keep one condition in mind that whenever you are doing so, you have to ensure that it is basically going to be a var string. If you're giving a val string, you will not be able to do anything with that. So one thing, this is something you have to keep in mind when you're concatenating your particular strings. Now, second thing is, even you have all the booleans being supported in your Scala. For example, you can say a val b is equal to, let's say you can say 1 greater than 2. Now, in this case, if you print out the b, it will return you false. As you can see, when it executed also, it made it false. So some conditions when you will place across also will work like that. I hope all of you are aware of what is the and or. That also is visible here. Like for example, I could have done this also. I could have said val c is going to be 1 less than 2. 1 less than 2. Now I created another one like this, and now I can say val d, and I can say b and c, right? So I can even define all these and or operator, like one and or, all these things we will be able to kind of define with that. Now this way we can play around with the simple statements of my Scala, like defining with normal data types, playing around with that, and basically changing all these things as well. Um, how much in your this session, if I ask you, are you familiar with simple coding practice like this? Because I don't want to spend too much of time on this. I definitely want to spend more time. How many of you are familiar with normal programming practice? Or I should in fact ask it in this way, how many of you are not familiar with this practice? Guys, can you hear me, right?
Yes, Shivang, we can say.
Hello?
Shivank, I think most
So
of us
from
have at least a little bit of programming back.
Okay, okay. So let's say when I say if loop, for loop, can I assume that all of you know it?
Yes.
Okay, then we are all good.
Yes, Shivank.
Then let's not spend much time over it. I think I just explained you the basic of it. I can do one thing. Maybe this scalar construct, I will give you few files which you can also walk through. That will help you. Maybe I will give you 4 files which I have with me. That will give you an insight how it works. In fact, let me open it if I have that. And I'm also gonna do one thing. This 1 second. Let me close this. So that we can spend more time on Apache Spark itself. Okay, look at this one. I just opened for you guys. So I will give you these files. Okay, this, as you can see, it have all the syntaxes being available for you. I don't want to go over all of them because if you already know it, just understanding the syntax in Scala. So take it more like a homework where you have to basically look at this if else loop, how we can write this match expression in Scala. You can also see how we can define this for loops, which is basically here. It's a very simple syntax way how we go about it. Similarly, how we can define this while loop and so on. So all these syntaxes will be available for you. You can basically look at that, and maybe that will be a good practice for you after this session itself. So this is something I leave it to you to do that, because let's not spend too much of time over this in order to save time. You can also see I've given some exercises also to follow up. Let's look at one more. Let's say if I come to this learning scalar 3.txt. Let me close this. The reason I'm closing this is because this is making my machine today slow. Tomorrow, let me install Apache Spark. This Apache Spark needs actually some more RAM. As you know, this is a RAM instance, right? So as soon as I will open the Spark shell, it kind of start asking for more RAM. Okay. So this is about the first part. Now, if I talk about this third component, which I've opened, learning scalar 3.sc file. So in this file, basically what I've explained is that how you can write your functions. So here you can see, and also one more thing, whenever I define any main function inside a class, we define it more like an object in Scala because I want to create an instance class from it, which can be initiated and can be run independently. So here you can see that all the syntaxes are defined. Like for example, I can say this function name, and then I'm defining this value as input as X integer, and the output for this is also going to be integer. So input is integer and output is integer. I can define it like X cross X, which is going to multiply these two values. And the way I would like to call this up, I will say square it, which is my function name. I can pass my input 2 to it, and it will return me 4 corresponding to that. So this way, I can even create these functions very easily in Scala. And one thing to note that I have to define it with the keyword def, because that def means definition for that, and it will return me the output for this. Now you can see another function, same way the qubit function you can also see. I don't need to explain that. This is very simple. This function is kind of important. I want to spend some time on it. So let's say you're creating a function f. Now what you're doing is you're defining your first input as x, which you're using it up, fine. Second input is a function itself. Now Scala is, since it's a functional programming, within a function also you can create another function as well. So that's something which is important. So here I'm saying that I'm going to pass a function which should take an input and return me also as output. Okay. So here I'm saying that, okay, inside this when I'm going, and the whole function transform it is also going to return me an output which is of integer type. Now what I'm doing, inside this function, I can do any operation. I just kept it very simple. I said, hey, go ahead and execute this function by fx. Means whatever f you're passing here, take the first parameter, which was my x here, x as integer, pass it as it is and execute it. Now, how I'm going to execute this? You can say I'm going to call this transform int. I'm going to take an input 2 and I'm going to pass my function name. If you recall, I've already created this qubit here, right? Because I've already created this qubit, now if I print out the result, what will happen? It will take like f of 2 as an input and it will return me an 8. Now, why this is critical? Because in Apache Spark, since we will also follow the same construct, so there also we will be passing a function within a function. So that's where this is going to become an important one. Clear everyone on this part? Because this is something new. Even if you're coming from Python background, this is little new for all of you. How we work with the function programming. If you already know function programming in Java or something, then great. This is pretty much similar. Any question on this part? Okay. I want one activity which I want all of you to do then quickly. I want you to write a code. What it is supposed to do for me. Let me open it here. I want you to write a code where let's call this as function f. Okay, you pass some integer value or basically whatever you want to. Let's say you say that it's going to be 23. Okay, pass another function to it. Let's say called as prime, or let's call it even. Let's keep it simple. Even. Just pass it even or odd, something like that. So if it is a so in this case, what should happen as soon as it executed? It should pass basically even 23. And if it's an even number, it should return true in that case, which is not going to be in this case. Otherwise, it should return false. Okay. So what should be happening in this case? When I'm writing this function, this should return me this output. Everyone clear on this part? So you have to write a function called as func. You pass two inputs to it. One is your whatever integer you want to pass. Second is basically your another function name called as even. This even function, what it do? If you pass basically an value which is an even type, it should return true, otherwise false. So in that case, this func should also return true or false accordingly. True or false accordingly. Okay. Just try that and send me your code in the chat box when you're done.
Shivam, can you please open the previous window for syntax?
Sure. This is the one.
Yes.
Can you all please check whether it's working fine now?
Okay, you have got that fixed already, Lakshmi? Let me see that. You guys can continue on the exercise which I have asked you to do. Meanwhile, let me just check it at my end.
Okay.
There is typo in Lakshmi.
Yes, Shima.
Hello. Hello.
Is there still I'm doing some typo here?
Yes, yes.
Oh,
After
yeah,
K,
sorry.
there is no H.
Yeah, sorry. I think I just added this without looking at it. Okay, it's working now.
Okay, thanks, sir. So I think it should work for everyone, right?
Guys, can you also check then, since it's working for me? Just can you have a quick check on this?
Yeah, it's working for me.
And guys, please don't use my VM. This is a request because if you try on different ports, it will just collide with the class and it will have an impact. Okay, I can see the code from Karthik. That's good. That's good, Karthik. Good, Ramnath. Only 2 people have done this.
Lakshmi not working for me yet.
Okay, was it Aditi or?
Yeah, Aditi, I will ping in the chat.
Sure. Lakshmi, can you please take all the email IDs again?
Sure, Aditi.
Anybody else? Just quickly check your accounts, guys. For whoever it was an issue or for whoever it was working also, please check your account. In fact, my suggestion is, can you hit this code, which I have just written? Can you hit this code? Just create an RDD, give a path with a subtext file and did a dot collect, because even my dot collect failed if you recall earlier. Then we will complete our Scala and then come back to our Apache Spark.
So I think it's only working for you, Shivank and Gauss, right? Others, if you can confirm quickly, Aditi, Grishma.
Yeah, I can see Grishma, Manju, Aditi, it's not working. Others, just check and let us know. Karthik not working. So when you're saying not working, is it like this command is not working for you, or is it like you're not able to connect itself? Not able to connect. Okay.
Like same error, like too many port numbers are appearing before us, like attempting port 4041 and then the line goes on till 4059 and then nothing is happening after that.
Okay. Have you tried that with the different thing which I send you across with the UI port? All of you who said that it's not working, can you try with the different UI port also, which I gave you?
Shivank, I've tried with random port numbers and it doesn't work for me.
Okay, the port which I gave you was what? Let's check.
5 ones.
Okay, that is also not taking up when you said -c spark.ui.port. Okay.
Lakshmi, it is not working for me as well. Previously it was working, now it is not.
Okay, so for Gauss, let's stop. Okay, that means you can just take up and let it know. Okay. Guys, have you completed this simple thing? I can see only 3 people have given me this output yet. Simple odd even problem. Done, everyone? Only 3 people have written. If you face any issue, please let me know. I can help you with this command. But get used to this because this is something we will do quite often in Apache Spark. Guys, whenever you complete, please send your code on the chat box. Last 2-3 minutes.
Sorry, Shiva, what we have to do?
Oh, you have not started doing? This was the exercise which you had to do, right? You have to create a function which should take an input parameter as 23, write an event function for it, pass, it should internally basically pass this value from it and return you true or false.
Yes, it is done.
Just send me the code then.
I have sent it above.
Okay, you already sent it.
Oh, I just pinged it to Lakshmi.
Send it to everyone. I'm reading all of your code. So I'm going to go very quickly over Scala, but at least the important things you need to know, because that's otherwise Spark you will find it tough. Okay, good, Aditi. You've actually done a good job by creating an object and all that. Okay, done everyone? If you're facing an issue, just ask me right away. Otherwise, you can just try it after some time as well if you're not able to complete. Or you can just pull up any of the code from the chat box. Like you can pull Aditi code. She have done a good job. Even I can see Karishma code. Yeah, that's also good. That's also a good one. Pull up any of the code. If you're doing a mistake, you can check from that as well. Now, I want to show you one more method. This is called as lambda expression. Okay. So what we can do also do is sometime if your code is really very small, it's not like a very big code. What you could also do is you can, instead of creating a function separately, you can just write that code directly here. For example, I could have given a complete different function. That's what we did in this even odd. And then either we can do it. Otherwise, you can just define it here itself. Means say whatever function name, you have all the values corresponding to it and can go about that. So you can see here, I've shown a lot of examples already here. So you can see that I have here as x cube. I'm going to pass through it. Similarly, here I'm defining it as dividing by 2, whatever value I'm going to pass through it. I can also define some functions, like for example, this even odd also you can do it here. You can see I'm writing multiple statements here, like val y is equal to x, sorry, x into 2, and then I'm doing y into square, right? You can write even multiple statements also, but generally it's a good practice if your code is small, then write it like that, though there will be no error even if you write a big code around it, but it's just that debugging will make your task very tough in case if you're writing a bigger code. So this is called as, please ask Aditi.
These are similar to the lambda functions that we have in Python, the anonymous functions, which are one-liners.
Correct. This is just exactly like a lambda function. We also call it as an anonymous function. We don't want to give any name because these are just temporary things. You will be finding this again also in your Apache Spark a lot used. Okay. Now, let me also walk you through one more last file, which is the fourth file. And here I want to just quickly show you few of the things which are important. Remaining you can walk through it later. One thing is this way, like I've defined captain stuff, I am defining in this bracket some values. So this becomes like my tuple. Okay, this is like my tuple. Tuples are immutable. Means you cannot basically go ahead and change some data around with it. And secondly, if I want to assess them, if I want to, let's say here you can see the brackets, first of all, make sure that this is going to be like this. Secondly, if I want to assess them, then I will be defining it by _1, _2. So generally we have a habit, right? That in Python and all, if I have a list like this, a is equal to 1, 2, 3, 4, right? Like this. Then I used to say a of 0th index like this, right? Sorry, a of 0th index like this. So in Scala, this is little different syntax which you need to be aware of. So here you will be defining it as _1, _2. So this _1 will return you the first element, not 0. You will not say _0. It will start from 1 here. So this is the way you will be returning basically the output from your tuple component. Similar way, you can also, yeah, any questions on that? Yeah, Aditi, you were asking something?
No, this thing got unmuted by mistake. Sorry.
Okay, no problem. Any questions from anyone on this? I hope this part is clear. This is a slight difference from your Python code or any other programming language if you're aware of. Now, this all the rest you can see it from the part. If you want to create a list, we do it like this. You can say list. You can define whatever you want, right? It's more again like a tuple only, but it's more mutable. You can go ahead and change whatever values you want to. Now here, if I want to, let's say, get the SS for one element, and this start from 0th index. So this will be my 0 index. This will be my 1 index. Okay. So now here, if I want to assess it, I have to say whatever my list name is, let's ship list, and I have to define whatever index I want in this bracket. Again, a slight difference. Like here, when I have to assess it, I used to use this bracket, right? But in Scala for list, we will be using this bracket. So again, a slight difference with your other programming language, which you have to also keep in mind while working on this code. Okay, so that's one thing you can again sort of follow. Any questions on this as well? No? Okay. I think Aditi again unmuted by mistake. Okay.
Sorry.
Thank you. You can even try all these functions like you have reverse, sorted. I think you are well aware of these functions. I don't want to talk about something which you might already know. So this is all about your Scala. I will give you all these 4 code files which I have written for you so that you need not spend time around in searching with this. Now we can completely target on our Apache Spark. So we are done right now already with our HBase. We have already understood how Apache Spark works. We have spent 1 hour to understand that full diagram itself. We saw a lot of concepts around it already. And further to that, we have understood Scala component and slide coding on the Spark. That is what we have done till now. Now, going further, like I said, we will be spending more time towards the Apache Spark side. Now, one thing is, just ensure that whatever code you are writing, if feasible, make notes as well along with it. Maybe you can note down these functions names as well along if you want. Because when I will give you case studies, now a lot of case studies will start flowing out once I complete some sections from it. As soon as those case studies start, they will all come together. Okay, so and every case study will have a different thing to kind of walk through. So that's there, and within case study you will be learning also. So you have to ensure that all the syntax you have written, you have to look at it, right, and all those things you will be performing as well. So make sure that if you can, if it is feasible for you, write notes around it. I hope all of you have already sort of written down this purple cow.txt. Let me bring this here. I don't need it for now. So for now, let me quickly create this file myself because I'm going to use it. So let me go here, create this particular file. 1 second. Let me make this bigger. File. Let's call this as purplecow.txt. Now in this file, I will be writing some code. Let me edit this file. I can say never seen a purple cow. I never hope to see one. Tell you how I did rather see them. Okay, this is the quick file which I have just written down. And what I will do now, I will play around with this file a lot. Perfect. I just saved it. Let me go to this part. And here, let me just change it to purple.txt. Okay, so this is my file. Let me do this collect, and I should be seeing quickly all the data. I hope not again, please. Meanwhile, it's running. Lakshmi, are you there again? Lakshmi? I was so happy it started working. Let's jump to this and this lab again. I'm just calling her, just 1 second. Okay, she will again go back and talk about it. Meanwhile, let's do this. If it do not work, because I need this lab, guys, otherwise it's very tough to handle this. I will do one thing meanwhile. I will cover up maybe some of the theoretical concepts which are required, which we will follow up in some way in that case. Just want to check Girish and Satish with you that will it be okay if we extend then tomorrow class to 5 hours? In fact, this is for everyone.
That should be okay, Shivank. We can do that.
Yeah, because I seriously don't want to just stretch it for the sake of stretching. And we end up facing this. This is very frustrating for me also. And tomorrow what I'm going to ensure is I'm going to install this Apache Spark in my machine itself. So that will be on my local system. So there will be no issue with this. But I also want to ensure that your labs are working, because the problem is you have to do all the case studies. That will become a challenge otherwise. So all of you have but every one of you have the Cloudera setup, or some of you don't have it? Just want to check on this. Is there anyone who don't have the Cloudera machine setup? Okay. Sure. So in that case, what I will do, I will just quickly explain you one more concept by 3:30 or something. And tomorrow, how about we start the session at 10:30 instead of 11, and we will move it till 4:30 anyway. And we will see that during the videos also if we get time. Otherwise, we have one more Saturday coming up. Anyway, in that case, whatever is left out, we can see if that class also required to be 4 hours or 5 hours. We can again manage that. Will that be okay? Surbi and everyone, what do you think about this part?
I think that should be okay, guys. Please speak up if you have any commitments. If you're fine, we'll take it as a yes.
So tomorrow class will be like 10.
No issues, Shivang.
Everyone okay with that?
Yep.
I will inform Lakshmi also to make this then tomorrow starting up at 10:30. Anyway, I will still talk for a few minutes. We're not ending the class right now, but it's just that since the lab is definitely required, otherwise it's of no point. So I have to sit on their head to get this fixed for you guys. So maybe tomorrow let's start it at 10:30. It will be like a 1 hour stretch. And today let's do some theoretical portion of this so that we can at least spend some maybe another 15 to 30 minutes on this exercise. Okay, sure. So again, giving you 2 minutes. If anybody have concerns, just let me know right away. If you have any commitment for those half an hour. I know 2.5 hours is also much, so I will give you a 5-minute break in middle. Okay, perfect. Let's get back. So we will do this practical tomorrow, but I can at least still show you my book and can show you few of the commands, which you can even try it later. Now, as a first thing, what we will be doing is, let me just explain you one quick thing. So if you look at this part, this is the same steps which we have done here. This portion is important. I want everyone attention on this, that what exactly we are going to do here. So there are 2 activities which I want to perform here. Number 1, I have a RDD. Let's call this as, let's say, RDD-A, okay, which is the purple cloud.txt. Now what I want to do as a first step, I would like to convert it to an uppercase as a number 1 step. So it becomes a uppercase. I will say RDD, and just to be making it clear, this is a Scala code and this is a Python code. Okay, so let's focus on the Scala part first, and then you can focus on the Python also. So now here what I'm going to do, in fact, this RDD name, let's name it as line because I'm using it here as well. No, let's call it as A. That's fine. Now, so what I'm going to do is I want to convert it to an uppercase. Now, first thing first, if I will say a dot map, okay, a dot map. Now here, look at this, what I'm doing. Remember, when I was explaining you this part, I was telling you that, okay, we will say a dot map and then some code which is doing this, right? I was saying this at that time. Now we will talk about that code. What is that code which we want to iterate? So here, what we are going to do in this case, this is going to be a line, which is going to be a variable. And what I'm doing with this, it's an anonymous function which I'm writing here. So I'm saying line, it could be any variable. You can also name it as Aditi. You can also name it as Effin, whatever you wish to. You are saying, but whatever you have defined here, let's say line, arrow, line, and then whatever function you want to operate on. Now what this is going to do for you. Let me come back and explain it here. So let's say, if I say here, A, my RDD A, which have the purple color.txt, map, some variable name, let's say I named it as Arun, arrow, Arun, dot, to uppercase. Now what this is doing at the back, number 1. Now I need your full attention on this, guys. This is very important. So what this is going to do for me, I already explained you, inside map, whatever code you write, it will execute this code on this RDD, right? That's the first step, which I explained you. Now what this is doing, so this code, it is just like this. When we used to create a for loop, we used to say for, and I used to say I coming from some number, and then I used to say, let's say print of I, right? Means I'm just writing in a generic way. So what used to happen? This num, what is your list of whatever you have? You are passing this data one by one to this I, and then you are printing this I here, right? That's what we used to do. Now here, what we will do in this case, here also the same thing is happening. This is just like a variable I. This is just like a variable I. So I'm saying that this data which is sitting in this RDDA, keep on passing to this Arun. Okay, take it variable by variable and keep on this. This will give it like sequential way. So it will give A completely here, and then it will start giving it sequential way, one by one line by one line by one. And then saying that perform this particular operation on this single data what we are getting. So what does this mean? This means, let's say I have the first line as, even if I can go back here and see this here. So what this is going to do for me. So what this is doing is, it will take the first line. It will say, hey, I have never seen a purple cow. I got this as a first line. Now on this line, apply this to uppercase and get it converted. That's the first step. Then this line variable will take up the second line and then it will make this. Similar way, the third one, it will return this. Fourth one will return this. So this way, this code get executed, and you can see it's a lambda function here. We are writing this function directly here instead of basically defining a function. Though if I would have wanted, instead of writing this here, I could have created a function somewhere else. I will also show you that code. I could have created that function somewhere else and could have just given the function name as well. That was also fine. But it is just a representation how this map will work for you. Any question on this part? Okay. Now let's talk about second thing. Second is your filter step. What is this filter step? I will come to that. For a minute, let's assume this is map. Let's assume this is map. Now what is happening is, let's say this RDD name is called as upper. Okay. So I'm saying, let's say upper dot map, and I'm executing this code. What is this code? Again, the same thing. On this upper, I want to one by one take it up and say it starts with capital I. So I'm only interested in the lines which is starting with capital I. So you can see this is my output, right? So what is happening here? If I would have used map here and then I'm running this code, it would have returned me this output. It would have said true, comma, true, comma, false, comma, true. I would have got this output if I would have done it using a map function itself. But I don't want that. I want it completely using my filter, basically as an output. Wherever true is coming up, I want that line to be printed. So if that is your condition, then in that case, you have to use not map, but you have to use filter. So what filter do? Wherever your output is coming as true, corresponding to that, you get your returned output. Everyone clear on this part? Let me make this clean. Look at the right side code. Ask me if you have any questions on this map and filter example.
Both are iterators, right?
Yeah, both are iterators. Everyone clear on this first part? Okay. Now look at the Python code also, just to have a quick view, because I believe a lot of you here already know Python. It's very straightforward. Here also, let's say I have an A. Here, the difference is I use lambda function. All of you coming from Python background must be already aware of it. Now, instead of using this arrow, in Python, we use this dot. Again, this variable, it could be Arun also, it could be Aditi also, any name is fine. Dot upper. This upper is my Python function. In Scala, the name of the function is 2 uppercase. In Python, the name of the function to make it upper is upper. Same way for filter also, you can say that line, and give any variable name of my wish, starts with capital. So this way, I will be able to also execute and see this result in Python as well. This is exactly the same way as Scala, but just a slight difference around it. Any questions on this whole slide now? This is actually very important because this is where we understood our first transformation function. Though we have not coded it, we will see that tomorrow, but at least you should have an understanding of how the map and filter works, the transformation works. Any question? Clear? Perfect. Now, let me show you how this whole thing is working here. Now, this part I have already explained you, this lazy evaluation. This is just in this book. I have sort of put this down in more detail. So as soon as you hit this first command, sc.expire, it don't add any data to your memory. It remains as blank. Then after that, if you again hit this map line dot to uppercase, then also you can see it created a new RDT, but it is also blank. Right now, there is no data being available here. Then after that, I hit my third statement, which is filter starts with capital I. Again, you can see this is blank. There is nothing available here as well. Then further to that, as soon as you hit count, because it's an action, then only it will go ahead and start filling the data and you get your response. That's an important thing to know about, right? I have already explained you, just that now you're seeing in more diagrammatic way. Now, one more thing in basically when it comes to your Spark or Scala, you can say, you can also perform your chaining. What I mean by that, instead of writing this code into separate lines, like you can see one separate line, second separate line, because if you look at it, what you are doing, you created this my data and you're calling this my data here as well. Same thing, right? No difference in that. So instead of that, you could have even changed it. You could have said sc.text5 purplecow.txt dot. I'm not creating anything now. I'm saying dot. And after that, whatever code is here, I'm going to place it here. Dot map this dot. Then again, after that, whatever code is there, you can write it here. Dot filter this dot. Again, that action also you can do in the same line. You can see it will give you also. Now, one thing is important here. Though this is available for you as a chaining function, it's like a shortcut for you. Nothing it's doing extra for you. But since it is available for you, one thing to keep in mind here is that this dot basically it will still create all the intermediate RDTs. So it's not like it will create lesser RDT. So here also we were creating like how many RDTs? One RDT was my data, then you have this RDT, then you have filter RDT. You are creating three RDTs. It will also create three different RDTs only, but it will give a temporary name for each of them. That is going to be one difference here. Clear, everyone on this part? Okay. I want all of you to go back and can you all write this code? For all of you, anyway, the labs of the Cloudera is working, right? Can you go back and write this code? Purple.txt, all of you must have already created.
The chaining function you want us to write?
Yeah, chaining function. Okay, it is done.
Shivam, let's say you make some mistake in this line, and how do you just stop that line? Like if you use Control C, it stops the shell.
If you do a mistake, you should be able to use an arrow to go back, right?
Let's say I don't want to use the arrow, like I just want to stop using that line and start in a new line.
Then just execute it, let it throw an error. And then you can again do an up arrow and fix it, or maybe you can write it. So let's say if you,
Okay.
that's what you do, basically. But let it go.
Okay.
Okay, Gaush is done, Manju is done. Gaush, where are you trying? On your Cloudera, or your lab has started working?
I'm working in Cloudera.
Yeah. Manju is also done. Guys, have you all completed? This is pretty simple, straightforward. This is the same thing which you can see in Python also. This is for Python lovers who know Python. You can see again, you can perform the chaining, and the same code which we have just executed, you can see that from here as well. Now here, there is one interesting thing which I want to show you. Though I will also show you from the Spark UI because that's where it makes more sense, but still you can see this output as well. When you do the final RDD which you got, you can say .toDebug string. What this is going to do for you, this is going to show you a complete lineage. Okay, so what this lineage is going to do basically here, this lineage is going to show me all the outputs. So here actually it will give the internal names for it as well. So here you can see it will say that, hey, I am using a filter in the last, which is a filter.dd. You can see this part, which is the last filter command. Then above that, I have a map RDD, which I'm doing it. So basically this is the name internally given. So it's just printing that name, which it has created. And the name will be corresponding to the function which you have written. So you can see that after filter, before filter, there was a map.dd. And even before that, you can see that we were using this sc.txt file. So you can see here, it will say that, okay, this is a map.dd and this is Hadoop RDD. Hadoop RDD means it have read the data from SDFS, basically sc.txt file. So this data is coming from SDFS and it is reading it from here. So this way, you can also look at your final lineage as well. Though this lineage don't make sense, like I said, I will show you more from the Spark UI. That will be much cleaner graph. You can see it in that format, but still you can get that. Now, all of you who have created in the last command, make sure that this is case sensitive. Can you all quickly hit with the last? So basically what I'm trying to say, if I come back to this syntax, so in this case, you must have maybe saved it like this, right? You must have said it like val, maybe some RDD name, let's say RDD is equal to, you must have hit this, right? So what I want is, can you now do RDD dot to debug string? Can you hit this command? So whatever RDD you have created, just say to debug string. You should be able to see your lineage. Quickly confirm me with this.
Yeah, sure. We can see like a log.
You can see the log. Perfect. So now this is the one which you can see from the output perspective of this. Even you can do the to debug string in Python also in the same way. And yes, so this is what you can see as per the output for the Python aspect. So I'm stopping here because the rest of the things I need to show you in code. I cannot show you just from this book like that. There need to be some practical activity going to happen. Let me ask you a few questions. So tomorrow class, like I said, 10:30 to 4:30, unless and until you receive any other communication over email, but it will be 10:30 to 4:30. Second question I have is, you have already seen that I'm using two programming language. Maybe I can include even a small context of Java later as well. But is this language neutrality is okay with everyone? That's the reason I even showed you how I mean this language neutrality. Or would you prefer to go with only one language and take it up? I'm okay with anything.
No, it's fine with two languages, I guess.
Okay. So anyway, this is very simple way you can even compare that what's the small change in the syntax and rest of the things remains the same. Perfect. Sure. So I'm stopping here, guys. So in this case, tomorrow we will connect and tomorrow class is going to be extended by 1 hour. So the amount we have lost like around some half an hour now and maybe half an hour here and there also we have almost lost. So it will be sort of covered during that aspect. So tomorrow class is going to be extended one. So basically we will be doing all the lab. Let me just start talking with the lab team now to see if we can fix this quickly. And for tomorrow, I will set up my own system with Apache Spark installed. Okay. And make sure that if anybody of you do not have the Cloudera machine yet installed, please have it because that will be required again tomorrow. Okay. And some of the data files which I will give you will be bigger. So maybe I will upload it in a Google Drive. In the start of the class itself, I will tell you to download it so that it can get downloaded and you can start working on that during your case studies. Okay, any questions from anyone?
Shiva, you mentioned that you don't need HDFS Hadoop system to install Spark. Is that right? Did I hear you correct?
Yes, you're right on that. So if I said that I'm going to use my Mac system to run Spark, definitely my Mac do not have SDFS, right? So somehow I will do some trick, which I will explain you tomorrow, that what is that trick using which I can read the data files present in my local file system. Okay. Apache Spark have this very strong thing that you can read your data sources are like you can be anything. It's not mandatory that you're reading it only from HDFS.
Okay.
We can read it from Jupyter Notebook also.
Yeah, from anywhere. Even if you want, I can maybe in one of the class I will show you how you can do with Jupyter. I already told you, right? Databricks. Databricks is nothing but Jupyter Notebook.
Okay. Yes, I am using a Jupyter Notebook.
Okay. Jupyter Notebook is actually superb. If you're familiar with it, you would love that. Especially Python people loves it. I also love it because it's more easier to write, looks more clean. I can make notes also there. A lot of things around that.
Yes, yes.
Shivang, can you?
Sorry, go ahead.
Yeah. Can you please show in the next classes like how we are going to submit to the cluster, like how we are going to build the jar files and all?
May not be feasible to reach by tomorrow, but if not by tomorrow, maybe on Monday it will surely come.
Okay.
We still have to cover a lot of concepts to reach that. It's very simple actually, there's nothing. But what I want to do is before I move to that part, I want to ensure that we have at least everything in place. Like then after that, what I will do is I will, you all are aware of Maven?
Yes.
If not, even without Maven also, I can tell you how to do that. It's simply, I will use an Eclipse. In Eclipse itself, I will also show you how to run the code. Then after that, there is something called as Spark Submit. This is a command which I will explain you in detail. So using this, you can have a jar being built from your Eclipse code. And once you have the jar, you can submit it on the cluster using that. So I will show you all that once the right time will come. Most likely it will be coming on Monday or Tuesday, not definitely tomorrow.
And talking about Spark, like, so we have been like dealing with files, right? Reading the files, right? So coming to the connectivity, can it connect to any other kind of databases like NoSQL or even RDBMS, that kind of thing?
I was not able to very clearly hear you, but if I understood it correctly, you said that, can I connect Spark with my NoSQL DB also? Am I right?
Yeah.
Yes, you can.
How about RDBMS?
Yep, you can. There are ways for it. In fact, RDBMS, I will show you the command right away. With NoSQL, this is a little tricky, but yes, I have connected myself. But generally, if you ask me, the way we do it is, if there's a very huge data coming in, we kind of use some connector. It could be Kafka. So what happens is this becomes my producer and this becomes my consumer. Anyway, I'm not taught Kafka, so I don't want to talk about that, but yeah, you can even connect using that.
Okay.
This is the industry way, means this is something which I do. Though you can directly connect, but then it's not like very trustworthy, I should say. So it's better to bring Kafka in middle, and then using this, you just transfer the data as per your wish.
So does the same apply for its connection to RDBMS database?
No, with RDBMS, it's very reliable API, which I will tell you tomorrow, I think in the first 1 hour itself. Okay, so that will come. I will tell you how you can just simply use that and it takes up your data very quickly. Any other question, guys? Okay, so tomorrow 10:30 is be available. So we are finishing it at 3:46. So we have lost almost half an hour because we thought to go till 4:15 at least. So yeah, let's connect early tomorrow then. Okay. Yeah. Thank you, everyone.
Thank you.
Thanks, Mike. Sorry, Shivank.